Good morning, participants. Amrit sir, are you ready?
Yes, ma'am. I'm ready.
Yeah, I would like to introduce Tulsi Prasad sir first. Sir has informed us that you would be continuing the session for 10 minutes and later he would be taking up the session. Is that true?
Yes, ma'am.
So we would like to introduce Tulsi Prasad sir first. In the afternoon, we'll look after yours, sir. Okay? Is that fine, sir? Can I introduce?
Yes, ma'am. Yes, ma'am. Please continue.
Thank you, sir. Good morning, participants. Dr. Tulsi Prasad sir is currently working as Associate Professor at School of Computer Science and Engineering, VIT, University, Chennai. Before joining VIT, he has worked as an Assistant Professor at School of Computing, Shastra University, Tanjavur. He received MTech and BTech in Computer Science and Engineering from JNTU, Hyderabad. His research interests are NLP, machine learning, and data science. He had conducted around 150 FDPs and workshops relating to machine learning and data analytics. He successfully conducted 6 short-term courses on advanced data analytics from Deakin University students, Australia. He is certified master trainer for associate analyst from NASCAM. He has published a couple of journals and authored a couple of book chapters in the areas of NLP and machine learning. Thank you so much. Amrit sir, you can start the session.
Yes, ma'am. Yes, ma'am. I'm sharing my screen. Is my screen is visible, madam? Please confirm.
Yes, sir. Yes.
Right.
You are visible, your screen is not visible. Visible? Okay, okay, sir. Okay.
Screen is visible, madam?
Yes, sir. Yes, sir.
All right. All right. Thank you. Thanks for the confirmation. A very good morning to all of you. So I'm Dr. Amrit. I'm also working with VIT Chennai. So I'll be introducing the topic big data analytics. What is big data analytics? Why it is different from other analytics approach or the conventional data analytics approach. And then I will try to take some case studies also. I will elaborate over the tools which are there with the help of which we can actually handle big data. So this is the outline of my presentation, the big data processing, tools for big data. What is Hadoop ecosystem, which is the tool which we can use for big data analytics. Then MapReduce, HDFS, and an example use case we will discuss. So first of all, given enough data, everything is statistically significant by Douglas Merrill. So if we want to have as much as data possible so that we can conclude some information from the data. If we have more data, so more accurate information can be deducted. Now to introduce the big data, let us have a different view and try to understand what is actually big data and why it is difficult to handle big data. Now you can see in this image, there is an elephant and there are 4 persons which are trying to figure out what is in front of them. Now there is one sort of difficulty which they are facing is that these 4 persons, they can't see actually. And the other thing is that they cannot communicate with each other also. That is also a constraint. So 2 constraints if we define. First is they can't see what is in front of them. If we go only with that, then the person over here, this person may think that it's a rope. The person over here may think that it's a wall. Here it's a tree and it's a house basically. So now how we need to figure out how these all these persons are going to figure out that what sort of shape is there in front of them, right? How they will figure it out. Now, that is the overall challenge which is there in context of big data. If we think about analytics of big data, the amount of data is so high that it cannot fit on one computer. So you have not a complete view of the data. You can consider that this part is accessible to this particular person over here. This part is accessible to this person. This person is accessing its own part, right? Now, another problem is that even if one person is traversing through the whole structure which is in front of him, then in that case he may forgot that the thing which he has experienced before, right? So if the person is moving from here and he reaches over this point, then he may forgot what was there behind, because he also have like a limited memory also, right? So in this way, we need to consider the big data and the challenges which are there in context of big data. Another constraint is that if they can't even talk to each other, in that case, how you figure out, how they are going to figure out that it's an elephant, right? So the person may be saying that they may conclude their result based on the data which they are having, right? Which the structure which they can experience, right? Based on that, they will conclude their result. And that result is not going to be accurate, right? So we need to come up with the approaches that we can mix up the results generated by these persons, right? And come up with the final result. And that result should be near to the actual structure, right? So this is just a view of understanding, not a very technical view, but still it's a view to understand what is big data. Now, there was one paper, big data mining. In that paper, that this technique was mentioned, this theorem was mentioned, HACE theorem, and it tries to sort of explain what are the properties of the big data. So big data starts with large volume, heterogeneous, autonomous sources with distributed and decentralized control, and seeks to explore complex and evolving relationship among data. That is what the whole big data is. We can summarize big data in this particular theorem. So we have some keywords over here. Heterogeneous, the data is coming from different sources. There are autonomous systems from which the data is coming. Then the data is going to be distributed and decentralized, and we know we need a decentralized control over the data. And the data is going to be complex. So the complexity of the data is going to be high, and data is continuously evolving. New data is getting added, incrementally. Every time new data is coming, you can consider an example of a sensor, and the sensor is continuously generating the data, which will result in an evolving system, right? So now, the basic definition which we can go for big data is that it's a collection of data sets so large and complex that it becomes to handle it using the traditional data processing applications. Traditional data processing application, I mean that we have basic machine learning approaches, we have basic database management systems, right? And it becomes very difficult to handle such a large amount of data with those tools. Now, there are few properties of big data. These are 3 V's which were actually introduced initially. Then these keep on increasing. Now we have 5 V's, 7 V's, and some other parameters also. But these are the core 3 V's which explains about big data. And these are volume of the big data, velocity, variety. By volume, I mean the quantity of the data is continuously increasing. Velocity, the rate at which that quantity is increasing, that is also high, and it's also increasing. Variety, the type of data which is there, it is like you have heterogeneous types of the data, right? So that makes up the variety. So you have these basic properties of the big data. And you can see all these properties are actually going to make difficulties also. They are the challenges in context of big data. So these characteristics basically going to form challenges in context of processing the big data. Now we have what kind of framework we need when we talk about big data. What sort of framework big data processing frameworks are required, right? So what sort of task these frameworks are going to perform, right? So at the center we have big data mining platform, And these big data mining platforms are going to work in these layers, right? So we have big data mining platform at the lower layer is going to deal with the information sharing and data privacy. And then we have big data application and knowledge. So these tools are going to deal with these aspects of the data. Then at another level, we have like how we are going to mine complex and dynamic data, right? And then local learning and model fusion. This I will explain. I am going to explain shortly. And then mining sparse, uncertain, and incomplete data, right? So big data is having these properties also, that the data is going to be very sparse because it is heterogeneous, coming from different sources. Sometimes you will not get data from all the sources, right? And the readings are also going to be sparse. Uncertainty. Why it is going to data is uncertain? Because there is going to be a lot of noise in the data, right? And the information which you may conclude from the data is not going to be accurate, right? So you need to perform some pre-processing because before actually going through getting some results from that. And data is incomplete. There are going to be a lot of missing values may be there. So again, you have to apply some data pre-processing. Now, another aspect which is there is local learning and model fusion, right? What do we mean by local learning? So if we can come to this example again here, this person is trying to learn locally from whatever is there in front of this particular person, right? So this person is going to learn locally. So there is local learning over here, which is happening. Then the next term is model fusion. Suppose local learning is happening, then how we are going to combine, how we are going to sort of amalgamate the information which is going to be generated by all these four persons, how we are going to actually combine that information. So we may have independent models which are being trained, which are learned from the different data, and then how we are going to fuse the information coming from different models. So this is a very important aspect about big data processing, right? Now, let me talk about the tools which are there with the help of which you can handle big data, right? It is not one tool, actually. It depends on the application which you are going to develop in context of big data, or the analysis which you want to perform in context of big data. So this we call Hadoop ecosystem. And in this Hadoop ecosystem, we have different projects under the umbrella of Hadoop, right? Now, what are these components? So we have Flume, we have Kafka, we have Scoop, we have HDFS, Yarn, MapReduce, Mahout, Hive, Pig, Solar, Storm, Zookeeper, and then Spark. And inside Spark, we have different components like GraphX, Spark Streaming, Spark SQL, Spark MLlib, Machine Learning Library, and then we have HBase and Cassandra. Right. Now, I will try to explain all of these components, or going to give you the uses of how these components are actually used and the purpose of their usage. That I will try to explain it to you. So first one is how we are going to get the data. So to getting the data, we have Flume, Kafka, and Scoop, right? So these are the data ingestion tools, right? How the data is going to be ingested to the Hadoop system. So we have this this particular Apache Scoop over here. What it is going to do, it is going to communicate with the relational databases, right? Initially, like if you have data in a structured form, then this Apache Scoop is going to communicate with that, right? So taking data from relational databases and enterprise data warehouses to your Hadoop system, we can use Scoop. And then we have Apache Flume. Now, if we have data in an unstructured manner or semi-structured manner, by unstructured, we mean the data is not having a predefined structure like a relational database, right? In a relational database, we have rows and columns, we have different keys associated with the schema, right? We have a predefined schema, but in this case, we are not going to have. So when we talk about unstructured data and we want to take the data to the Hadoop system, then we can use this tool, Flume, right? Then there is like where we are going to and how we are going to store the data in Hadoop, right? So we have this Hadoop HDFS. What we mean by that, Hadoop distributed file system. Now, what is the idea behind Hadoop distributed file system? It started with basically with the GFS, that is Google file system. And there at Google, they tried to combine the storage of the commodity hardware, or by commodity hardware meaning the systems which they were having in their office. They tried to combine the storage so that they can come up with more storage. So a kind of file system, right, which work on network. So the idea behind HDF is the same, that the commodity hardware are going to be combined to store the data, right? That is what is like the objective is. And then the data stored close to the CPU, right? For example, here we want to store some data, then the data is going to be stored over different systems. So we want to store data over these different systems, right? And we can store data, like if we have a file, the file is going to be divided into different parts, and that file will be stored in a distributed way. So we don't want certain specific hardware. Whatever the hardware is available, we want to store the data over that particular hardware. Now, another aspect is that it is discouraged actually to take the data to the processing unit, right? So we want to store the data wherever the data is. We want to put the processing unit there itself. We want to discourage the data communication, and we want to encourage the information communication. We want to information sharing is more encouraged as compared to the data sharing. So data sharing we don't want to do. That is why locality is very important. Then redundancy. Like in case of any failure, like of any system, then we should be able to recover the data which is stored. And then there is a simple abstraction. What is the meaning of simple abstraction? That it seems like even if you deal with the HDFS, even in that case, what is going to happen? It will be like that the data is stored in a local file system. So we need to manage the data in such a way, or the data is going to be stored in such a way that you can directly access it. You will get a file system. You get the directories. You don't have to bother about from which system the data is actually coming, right? So this HDFS is going to provide that abstraction also. Then there is one processing aspect of the big data, that is MapReduce, right? MapReduce. What is the meaning of MapReduce? HDFS is purely for storage, right? And it provides the abstraction for the storage, how the data is stored. And then another aspect is that computation abstraction, how the computation is happening over the divided data, that will be handled by the MapReduce, right? So now what MapReduce helps actually, so it is going to allow the programmer to specify parallel computation without knowing how the hardware is organized. So you need to develop programs using MapReduce, and those programs are going to be executed over distributed systems, and the results are going to be produced in that way, right? So this is going to help the programmer so that distributed programming can be done, right? We can define that what sort of tasks we need to perform in a distributed manner. That can be done using MapReduce. Then we have Pig and Hive. So Pig is basically a scripting language, right? And with the help of Pig, what can be done? And there are different aspects of the Pig. This Pig is going to provide high-level data processing. It's a high-level data processing language, and you can perform numerous operations using this particular Pig language. So you can access your HDFS right? Using PIC without developing MapReduce code. So if you write few lines of PICs and you can access the data instead of writing, say, hundreds of the 100 line of codes of MapReduce. So again, this is going to convert the task in form of a MapReduce task and going to access the data from HDFS. It's a script which is there, right? Okay. And then we have Hive also. Hive is also like it will provide you feel of structural query languages, SQLs, right? So you can have a Hive command line and JDBC, ODBC drivers, which are there when you connect any database with, for example, if you want to connect with Java, then you use JDBC, right? So it is going to provide the a familiar syntax to access the data. Again, this Hive is again going to connect with the HDFS, which is there, right? So Pig and Hive are going to help you to access the HDFS data in a way which is more close to the relational database, right? That is what these Pig and Hive are going to do. And then we have, like in our ecosystem, we have this Spark, right? So for Spark, what is there in context of Spark? Spark is like MapReduce provides you the processing part, but it is slow. Everything is done on disk, right? All the input-output operations are going to be performed on disk. With the help of Spark, you can do in-memory computations, right? In my afternoon session, I'll be discussing more about Spark, right? And then we have Yarn, yet another resource manager. So what is this Yarn? Basically, it is going to manage the different resources which are there. So it is going to manage the RAM, it is going to manage the disk, right? It is going to manage the processing power, all the CPU cores which are there. So before, like in the early versions of Hadoop, it was not there. Everything was managed by MapReduce only. But later on, this Yarn introduced, and it is a resource manager here. Right. Then we have Mahout, which provides some machine learning libraries along with MapReduce, right, to apply machine learning algorithms, right? And then we have Kafka over here, right? And this is also used for ingestion of the data, and it provides like distributed streaming platform, right? This Kafka. With the help of this, we can store stream of records. So if you have some application which is running, and it is going to provide a messaging system between different applications, so that a message protocol is going to be established so that the data can be ingested into HDFS, right? That is what the purpose of this Kafka is. And then we have this this particular Storm is here, right? Storm is there, and Solar is there, right? So what these Storm and Solar are going to do? So Solar is basically this particular Solar is going to provide a search engine, right? It's a kind of search engine. So you may have seen, like when you visit Flipkart, even if the data is in sort of unstructured form, you apply different filters, right? So this actually this Solar is not very new. It was old only, but it got very much attention when this Hadoop came and HDFS came, because the data was unstructured. So it is going to help to apply different filters, and it speed up the process to filter out the results, right? And then we have Zookeeper over here, which is going to sort of integrate, which is going to develop communication among these components. And we have HBase here, and it is NoSQL based, right? So when we talk about NoSQL, so that is what we need to understand, HBase, and this is distributed database system, right? It is going to provide a distributed database system. Again, this also will be handled by Zookeeper, how the communication is going to happen, and this HBase is going to interact with the HDFS, right? And then we have a Cassandra also, where based on which we can develop applications which are using all these components of the Hadoop, right? So this is a mere introduction of Hadoop ecosystem, right? How these different components of the Hadoop are going to work together to fulfill the requirements of analysis or any sort of application which you are developing, right? Then what sort of research problem and a generic idea is there in context of big data? So the generic idea about data analysis is that you are given with data and you have a data processing unit, and then you are going to generate the information. Now, the problem here is that in context of big data, the size of the data is very high, it is complex, right? So all sort of challenges are there. Now, what is the solution to this? How we can approach to this particular problem? The approach is very simple, that we have data source, right, or complete data. And then the idea is that we want to divide this data into different parts, data set, subsets. Not actually subset, we can have replicas also, right? And then see the locality of the processing unit is actually attached with the location of the data itself. And then the information is going to be generated, right? Let us generate information in this way. That is a generic solution. Now, what are the challenges in this context? What are the challenges that we need to understand? What are the specific challenges in context of research also? Now, these are the problems which are going to be addressed, right? So we have large data, huge amount of data, whether it is already stored or whether it is getting streamed from different sources. And then we have data processing, data pre-processing, right? So we need to question us that, do we need data pre-processing, right? So is it required or not? If it is required, again, is it going to be performed over the complete data? If it is going to be performed over complete data, it means that we need this complete data in our memory, right? That is a challenge. Then we need to understand whether the division of the data is possible or not, right? Is it okay to divide the data? Sometimes it is not promoted to divide the data. Can you divide the data? So that is also a question. And when you divide the data, then how you are going to process these subsets of the data, right? How you are going to divide it, how you are going to process that? That question need to be answered. Now, while this processing is going on by the different processing units, these processing units are going to communicate with each other? Like in the example of the viewing the elephant structure, are those persons are going to talk to each other or not to actually find out the actual structure, right? So that is again a question mark. If we can decrease this communication while addressing one problem, if we can decrease this communication, then we can say we are improving over the existing work, right? Can we decrease this communication between the two independent processing units? Then what sort of information we are generating from each processing unit? Are we generating information or we are generating simple sample of the data? So both are different, right? We are generating information or we are just reducing this data to a smaller amount, right? And then how we are going to combine the results so that we can get a final analysis. So this processing unit may result, you can fit any classification example over this particular diagram. How you are going to fit a classification? Given a large classification data, you have divided the data and all the different processing units are working over the data. It is this particular data is either maybe reducing the data or it is saying final label for the class. So all of these processing units are telling you about the labels of the data, right? Now, what final label you are going to generate? How you are going to mix up this information, right? The similar task is done in ensemble learning, but how we are going to do it over different systems, that is a question, right? So all these challenges are there in context of analyzing big data, right? And then I'm going to take an example problem. So for example, you want to find sum of n numbers, if you want to find out. Now, can we divide, for example, we have say 1,000 numbers, right? 1K numbers we are having, and we have divided these numbers over different systems. So on one system I have 200, another system I have 300, another system I have 400, and on one system I have 100 numbers, right? Can we find the sum of 1,000 numbers, right, over different systems? So we can do that. We will find sum over here. So sum 1 here, sum 2 here, sum 3, and sum 4, right? And if we fit this particular problem with this, So this system is actually generating some information, which is the sum, right? And finally, how we are going to sort of combine this information, we can simply say that we are going to add them up and generate final sum. We can generate final sum like this. All right. So that is very easy. Now, see here, is the communication happening between two systems? The answer is no. They are not sharing any intermediate result while the calculation is happening, and all the calculations are done over the systems only, and we have a simple linear sum which need to be performed over a central unit, right? Now you change the problem to find the average, right? Can we do that? Can we do it in this manner? 200 points over here, and we find the average. If we find the average of 200 points in an independent way, can we combine that? Can we combine that? Right? That is a question mark. Can we calculate the average of, say, 200 numbers and then 300 numbers on different system, and can we combine the average? The answer is simply no, right? We cannot do that, right? So it means that we need to change our plan. The plan is going to be, now we need to modify the plan. The plan is going to be, now if we want to find the average, in that case, what we need to do, we need to, what we are going to communicate here, we will communicate the sum. We will communicate the sum. So sum 1 and count 1, right? As we have increased the number of parameters which are getting communicated to the central unit, the complexity, like we will say that yes, like amount of communication got increased. But that is how we can approach to this problem. We will sum them, and we will sum all these sum variables, and we will sum all these count variables, and then we will be able to find out finally the average, right? Now, again, you can think about similar problems, right? You want to find out the standard deviation. In that case, what you are going to do? Given n numbers, you want to over different system, and you want to find out the standard deviation. How you are going to do? What sort of information you want to pass on to the different system, right? So all these kind of problems are there. When you think about taking any problem to a distributed platform, you need to think about, can this problem be solved in a distributed manner, right? That is the question. Okay, so you want to find out, you have some data set which you want to divide over different. So now this 1K, you consider that these 1Ks are rows in your data set, and those rows are divided. Now you want to perform some analysis over that in an independent manner. Then what sort of information you want to communicate, right? So for that, I have one example over here. This is a very basic, like first data mining algorithm, which is there, which is the a priori algorithm. Now the approach for this algorithm is like this. Some items are given. So these items are, let's say, bread, butter, and milk, right? So these items are numbered, and each transaction over here, TID means the transaction. Each TID represents the ID for that transaction. So some person is like, customers are visiting the a general store, and they are purchasing the item. So in that way, this data is getting recorded. And this you can see that some person is there, like that problem we addressed actually, some person is starting from home and going to his or her office, and these are the IDs of the mobile station which that person is visiting, right? So this particular type of data set you may find in different domains. Like I've given you example of mobile. Then we want to find out the most associated mobile towers, right? We want to find out those so that the service can be increased, right? Here it can be considered in context of a market basket problem, right? Now the idea is that we want to find out the dependence among two items, so that if we put one item on sale, another one, the price of another one can be increased, so that the overall profit can be increased, right? So the more associated items we want to find out. The approach is like this. This is the basic data mining approach. The approach is like this. We are going to scan the complete data set, right? And we are going to generate the count, which is the technical term is support for each item. So support for each item that how many times one is coming alone, right? 2 times, and this is coming 2 is coming 3 times, like that this is going to be. And then there is one parameter which is minimum support. If some item is infrequent, that item we are going to ignore, right? So this item we are going to ignore, and then we generate another frequent item set, which is this, right? So we have 1, 2, 3, 5. These are the items which are frequent. All right. Now, based on that, we are going to do a crossover over here for all the items. And if we do crossover, what we are going to get as result? So 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. You do the crossover. And the order does not matter. It's a set, right? So now we are going to find out the frequency for all these, right? The frequency is going to come like this. Now, again, we can remove the infrequent item sets, right? And we left with these. Now, again, if we perform the crossover, we get, after eliminating, we get this particular, these set of item sets. And then when we perform crossover, we get this item set, right? 2, 3, 5. And this is what we are going to get, which is having some support, right? Okay, so this is having support more than what we set. The minimum support we are considering as 2, which is like either 2 or more than 2, the item set should be there, right? So this is the frequent item set, which is actually getting calculated, right? Now you consider this same data set, right? The same full data set is there, but the data set is so large that you cannot fit it into the main memory. The problem here is that while you are doing crossover, counting is okay. Counting you can do. But when you are doing crossover, at that time, how you are going to perform that, right? You need complete data. You need all the items to do the crossover. You need everything in the memory. But if the data is not fitting in the memory, then how you are going to do that? So it's a kind of centralized approach, and it's a complex one, right? So how this problem can be solved in context of big data? What is the solution? The data set is going to be divided like this, right? So this is a very simple example, but consider this part is available on one system, this part is available on another system. You can consider your laptops, right? So we have 58 participants, and this, say the data is like we have 1000 K data, and that data is divided over those 58 laptops, right? Now you want to perform this, and you want to come up with this particular final item set. And the constraint is that you should not talk to each other, or the communication need to be minimized. And there should not be any data communication. And even if it is there, you need to minimize that. Again, problem of minimization is there, right? How you are going to approach to this problem. So there are different variations of a priori are available, right? So like I'm going to give you one example. How we can approach to this particular problem, right? What sort of information we can share? We can share the count for each items, right? Again, that is going to result in some communication. So that I will describe using this particular figure. We have like, we need to maintain global counts for each item, right? The idea is that you maintain global variables, right? And then like, what are the questions we need to ask to each other, that we have a centralized system and data is divided over those two systems, like I marked there in the data set itself. And then we will generate counts. And this counting is going to be performed multiple times. First, you are going to count singletons, then you are counting doubles, then triplets, like that. In that way, you are counting, and you are always communicating with the centralized device, right? And that count is first getting communicated with the central node, and this central node is combining the count coming from different systems and then generating the global counts, right? So count for item 1, say item 1 is coming from this system, and item 1 is coming from this system. Then finally, the count for item 1 is getting calculated over here, and that global count is passing to all the systems, right? And then they are coming up with the pair, right? Count for 1, 2, 1, 2 again, they are calculating. So sort of this communication need is happening in an iterative manner, right? So that is a simple approach. That is a sort of a naive approach, right? Again, what are the question? Whether like how we need to sort of come up with some better solution, whether global reads are required or not, global reads, global counts are getting communicated or not, how many iterations are required, are we using shared memory or shared storage, right? What sort of model it is to address the same problem of frequent item set mining, right? So again, you can see that there are different computers, P1, P2, P3. They are working on their own partition of the data set, and they are generating the counts, and counts are getting communicated, right? The infrequent item sets are communicated, right? In this way, they continuously need to exchange the data, right? And these were the existing approaches which were there. So an example is this MapReduce. In a MapReduce manner, how it is going to be done. So consider one mapper is working on a system, right? So the data is divided like this, and these are different CPU cores, or you can consider them as different systems also. So each mapper is going to generate a key value pair, right? So a mapper A is saying that the item A on my system is occurring 2 times, B is occurring 1 time, 3 is occurring, C is occurring 2 times, right? So in this way, each mapper is going to generate the information. At reducer, we are going to combine it, right? Again, this information is going to be shared back to all the systems, right? This information is shared back to all the system. Okay, so now you see.
Sir, excuse me.
Yes, sir.
Participants are requested to mute yourself, mute all. Amrit, sorry, I'm making it mute all. Please on from your side.
Okay, ma'am.
Okay. Okay, sir.
Okay, ma'am. Now you see in this case over here, the global counts are communicated back, right? Global counts are going to be communicated back. And you see that 3 systems are working parallelly. They are generating some information. The information is getting combined, and that information is again shared with 3 laptops, right? If I use this term, right? And then again, next iteration also, same things are happening, but we have these pairs now, right? In this way, this particular technique need to be addressed if we want to do it in a distributed manner. All right. Now, the solution, how we improved it, the solution is like which we proposed actually. So we came up with the approach so that we can provide some weightage to each system. I'm not going to explain the approach, but I'm just giving an idea that we provide weightage to each systems, right? All the system we are going to provide some weightage based on the data which those systems are having. And we try to find out the final answer which is close to the original answer. So here we can say that while when we are finishing the calculations, we will have final frequent item set. And based on that, we can say that these 2 items are associated with each other or not. And that answer is going to be in terms of probability or percentage, say 90% time, the 2 items are dependent on each other. If like 90% time, we are saying that if one item is purchased, another one is also purchased, right? So that sort of analysis we are going to come up. Now we try to distribute it in the approach which we did is like this, that we need to provide weightage to each system, and that weightage we have calculated by applying some mathematical approach over there. And that confidence, that weightage, we are calling it normal DJ, where J is the number of, J is varying over the different nodes, right? And we find the Ri, which is the relation, say item A is associated with item B, right? And we try to find out this weightage. Once we are done with that, and then that is the final weightage we say. So if the answer is 90% actual result, and we try to achieve it, say 89% or 88%. So with some error, we are able to do that, right? In one of our approach. Okay. Another is like we try to come up with a tree-based approach. In this tree-based approach, we try to come up with a tree data structure for representing the dependency among different items. So we have a root node. After that, we have a very frequent item set. Then under that, we have some frequent item set, but less than this, right? Less than this frequent. So in this way, we try to generate a tree from all different systems. So I'm representing these trees, 4 trees, meaning that I have generated them from 4 different systems. And then we try to combine these trees, right, based on the nodes. So same nodes are going to be combined, and we come up with a final tree. This tree are like they are shown very small here, but the size is very big, right? So each edge, if I zoom in, so it's like this. So each node is kind of numbered as item, and the items are how these items are connected. So we have most frequent item at the root, and then we have little infrequent at the childs, right? So we don't go with the sort of the edge nodes, right? We find the longest branch of the tree, and that is what we say that is the frequent items, right? So that side of analysis we need to do. Now, the overall idea is that how we can actually divide the original task of analyzing the data, so that we can come up with a small task which we can do on different systems, and finally come up with the result. Now, you can come up with 2 approaches. You can come up with 2 types of approaches, whether you are reducing the data, or you are generating the information. Another question is that how you are going to combine the information, right? So for doing this, you first need to understand different data analysis approaches, right? So that will be taken care by sir. Tulsi sir will take care of the data analysis approaches, which we need to understand, right? So that's thank you from my side. If you have any doubt, you can ask me. Ma'am? Tulsi sir? Okay, sir is not able to unmute himself. Ma'am? Deepika ma'am? Am I audible? Participants, am I audible? Sir, am I audible, sir? Madam?
Sir, audible.
Okay, ma'am, please allow Tulsi sir to unmute.
Yeah, we are
himself.
doing, sir. We are making him co-host.
Okay, ma'am. Okay, ma'am. Thank you.
Co-host. Make him co-host. Deepika Lanjani or stay? Or else allow him. Otherwise, we'll do here. Hello? Hello, Tulsi sir. Please, others, stop your videos.
Yes, ma'am.
Tulsi sir.
Yes, ma'am.
Thank you so much. Please continue.
Please. Thank you, Amrit sir. Thanks for the opportunity. Am I audible?
You are audible, sir. You are audible. Perfectly audible.
Thank you, ma'am.
Okay, sir.
First of all, let me thank Amrit sir for putting all the big data technologies in a nutshell within 1 hour of time. Why? Because probably if we take this particular course, it will be around 1 semester for the students. But he tried to put it in a nutshell within 1 hour of a time. So from my end, is my screen visible?
Yes, sir. Visible, sir.
Yes, sir.
Thank you, sir. Thank you. Thank you, ma'am. Today, we are going to understand the introduction to the data analytics at a primitive level. My assumption is here, nobody not aware of anything about the analytics. If you already finished the course on data analytics, probably it's slightly a boredom for you. This is myself, Tulsi Prasad. Currently, I'm working as associate professor in VIT Chennai. Prior to this, I worked as senior assistant professor at Sastra University. I'm the certified master trainer for NASCOM Associate Analytics, and these are my areas of interest, like natural language processing, machine learning, and data analytics. This is the agenda for our session today. First of all, let us see why do we need data analytics. Then we will try to understand what exactly this booming term called data analytics nowadays. And what if we are using data analytics in our workplace, either in academia or industry, what kind of benefits we are having with the data analytics, we will try to understand. Then what are the different flavors of data analytics we will understand within this session. Then we will try to see how a typical data science life cycle looks like, and what are all the tools that are required in inculcating or for establishing data analytics in a workplace. Then finally, I'll show you some of the data science or data analytics competition forums where you can participate and where you can improve your knowledge. The first question arises whenever we were learning any course or any skill set. The first question arises in our mind that why do we need to study that particular thing? Yes. So the question is here, why do we need data analytics? If you see here on the x-axis, you can see the year, and the y-axis, you can see the volume of data that was generated in terms of zettabytes. You can clearly see from 2010, actually this is the predictions given from statistica.com. So what they are saying that from 2010 to 2025, so the data explosion, if you see, there is an exponential data growth. So this particular thing is clearly convincing us to study the course of data analytics, to understand data analytics. Along with this, you can see one infographic on my screen. Can anyone guess what it is? Participants? Have you ever seen this infographic? Maybe some of the professors have seen this. Yes? No? So this is called 1 minute internet time. This is in 2022. In 2022, this much of data we were generating within 60 seconds of time frame on the internet. You see how much data we were generating. 28,000 subscribers, they are watching OTT sort of platform like Netflix. And you can see this many stories they have shared on Instagram. Around
Once again, just participants can respond in the chat box, whatever information you would like to tell, because if you make the session interactive, then only it will be enjoyable. Thank you.
Thank you very much, sir. Thank you, sir. So you can clearly see how many connections they made on a professional platform and how many messages they are sending. Even you can see not only the communication, you can see how much money like they spent over online on this 60 seconds of time frame. This one is clearly indicating that we are producing huge humongous amount of data, and we need to utilize that data for future. And here I have given you another link. What are the big data statistics in 2023? I'll be sharing this presentation with the convener. You can get it and you can see how the statistics are for 2023 with respect to the big data. And as per industrial revolution, you can see from industry 1.0 to 3.0. Now we are traveling towards industry 4.0. Here, people are saying about ML and AI and big data analytics. Not only this, this is one of the technologies that were fueling the industry 4.0. If you see most of the conferences, in most of the webinars, people are talking more on industry 4.0. So what industry 4.0 is telling about the technologies is they are telling additive manufacturing, augmented reality, autonomous robots, simulation, and industrial IoT, like Internet of Things. Along with that, they are emphasizing more on big data analytics. So these are all the statistics and these are all the... Sorry, Santosh sir. So these are all the things which are clearly showing us the importance of data analytics. Let us, not only with this.
Participants, mute yourself, please mute yourself. Participants, please mute yourself. Do not disturb the session. We request you. Please mute.
Thank you, ma'am. Along with that, you see there is a big demand for the, what do you say, data scientists and ML engineers. So we don't have that much skillful people. So if you study this particular course, probably you will get high salaries. You see, even Glassdoor, they have conducted a survey and they told that US national salary is around 118 something. This is the salary of a data scientist. And you can see clearly that it is 163% higher than the national average salary of the people. So why I'm showing all these statistics to tell you the importance of this particular course and the particular field. And some of the people, you may be thinking that if I'm doing this currently, after a few days, whether this will be stable, this course or this particular technology will be stable or not. Yes, answer is yes. Why? Because you can clearly see that so many fields here. You can clearly see that so many fields. So these are some of the fields only I have kept for your understanding's sake. Everywhere we were producing the data. In academia, let us say, which course I need to offer in a particular sequence. Yes, so like this, even in government, if they want to put a policy upfront to the what is this society, so what kind of thing they need to understand. And COVID has clearly shown, we witnessed in the drug development and all, how data science and data analytics help us in identifying the drug interactions and all. Yes, so it is very, very important thing you need to learn and you need to understand. So far we have seen why we need to study this particular, or why we need to understand this particular course called, or topic called data analytics. Let us try to define what exactly data analytics is. Data analytics is the process of exploring, analyzing the large data sets for finding the patterns and unseen trends and discover correlations and derive valuable insights to make business predictions as well as business decisions. Maybe some of you heard about a particular saying called, decision making is one of the difficult tasks in our current world, whether you will agree with my statement or not. There is a paradox called Boolean's paradox. What they are saying that if you keep a donkey which is hungry as well as thirsty, in front of that donkey, if you keep a pile of hay, grass, as well as a bucket of water, can you guess what will happen? There are two choices in front of the thirsty and hungry donkey, and there you have given the bucket of water as well as a bunch of grass. Because of these two multiple choices, the donkey can't decide whether it needs to take water first or whether it need to eat grass first. Yes, but data analytics are very much helpful in making business decisions. So let us try to understand what we were doing with this data analytics, what exactly the exploration and analyzing data sets in the upcoming slides, and how do we identify the patterns and trends, and how do we identify the correlations, and how do we see the hidden insights from the data we are going to understand in the upcoming things. Even this particular diagram may be giving you the idea of how this particular thing you see here, they have given the data, and by using analytics, you are able to see some pattern here. So this is the pattern. And if you are using this particular technique or the technology in your workplace or in your research or anywhere else, you will be getting so many benefits. US Bureau of Social, Economic Analysis, they have conducted a survey on benefits of data analytics, and they gathered the responses from the top-notch people, and they put it in a pie chart like this. What industry top-notch people, they are saying that while they were using data analytics in their workplace, they are getting better decisions, as well as it will be helping us in enabling their strategic initiatives. And some of the companies, they are saying that it will help us in keeping the customer relations in a healthy manner. And some of the companies, they are saying that while inculcating data analytics in their industry, they are able to sense the risk in a better way. And some people, they are telling that they are having a better financial performance and financial plan while they are using data analytics in their organizations. So who are all the guys getting benefit from this data analytics? So here I kept very few verticals. Not only this, wherever the possibility of data, there you can use data analytics, and you can get benefits from the data analytics. So if you see how the data is moving and how the way of applying analytics also moving, we can see from this particular infographic. In 1975, before that, people talked more on data analysis part and business intelligence. So there they more talked on the past data, historical data, what they are already having, and they try to understand that. Whereas in analytics 2.0, where big data came into the picture, prior to that, companies and organizations, they used to see the data which is existing in their organization, but they never look into the outer world. But after getting big data into the world, and social media platforms that are getting into the world, organizations are not only looking within the organizational data, they were trying to get the insights from the outer world data also. Like this, you can see how the analytics evolution has taken place from analytics 1.0 to 4.0. Now people are looking more on cognitive and automated capabilities, like how we were trying to mimic a human being by using deep learning and various other neural network techniques. Similarly, can we automate this decision-making policy? They are looking in the analytics side. And if you want to see how these trends are, you can look into this. Maybe some of you already known regarding this Google Trends. Have you ever seen this? Like if you want to search anything, how popular it is, how trending it is, you can make use of this. Even the blue colored one, you can see it is about data analysis. You can see it is at the lower end. From 2004, you can clearly see, and after 2017, again, it is booming up. And here we have shown another important search phrase called data mining, that is in red color. And you can see business intelligence. Now this one you can see data analytics. Even this one will help you in understanding in a demographic, in a geographical way also. You can see the color coding is clearly indicating which particular thing, the green colored one. You can see Russia and even India and all, what kind of technologies they were popular. You can clearly see with this Google Trends. Let us try to understand what exactly the different types of data analytics and what are all these different flavors of data analytics we will try to understand. Basically, the data analytics are categorized into 4 types. The first one is the descriptive data analytics, and the second one is diagnostic, and the third one is predictive data analytics, and the last one is the prescriptive data analytics. So what descriptive data analytics is, if you can see x-axis and y-axis, the value while you are inculcating each type of data analytics, how you are adding value to your business, and the establishing complexity also you can see on the x-axis. Yes. For establishing descriptive analytics, complexity is not that much. Even you are not getting that much value. But while you are adding one by one, like diagnostic, predictive, and prescriptive, you can clearly see you are adding value to your business, as well as on the other side, it is increasing the complexity of the establishment. First, let us try to understand what exactly descriptive data analytics is. What descriptive is, it is trying to understand what has already happened. So something has happened, that one you can clearly understand with the descriptive data analytics. We will discuss in detail in the upcoming slides. And a diagnostic, something has happened, why that particular issue has happened. If you want to understand like a detective, that is called diagnostic. And another, the next one is called the predictive data analytics. So with this descriptive and diagnostic, you are thinking that the same sort of thing may happen in a future. You are trying to predict the future, what likely to happen by observing the history of the patterns. That one comes under the predictive analytics. After predicting the future, what course of action you need to take for handling those situations, that comes under prescriptive analytics. In a nutshell, if you ask me to put it, how a doctor, you see, whenever you are having some problem, we will be visiting the doctor. What doctor will ask? Doctor will ask some sort of questions. He will tell, do you have regular fever, a regular cold, regular cough, body pains? Like that, what he's trying to do is he is trying to understand what are all the things that has happened past to that particular person. By observing these things, what he will do, he will ask us to go for some medical tests to find out the reason for happening these events. That is the root cause analysis. Yes. Once your report comes, what he will tell, if you are following the same diet and following the same sleeping patterns, probably in future, you may get into an undesirable situation like this. That is called predictive. If this thing is going to happen in future, so what kind of course of action you need to take to mitigate this particular problem? For that, doctor will give you the prescription, like what are all the things you need to use. The same way in a business organization, organization and the companies, they were trying to take their data and trying to perform descriptive, diagnostic, and predictive and prescriptive analytics to take better decisions, to improve the customer interactions and various other things they will be getting while using all these four kinds of data analytics. So I told you that descriptive analytics is trying to identify the patterns and the relations. Like patterns, like if you see, if you ask me my phone number, I will tell like this. This is my pattern. Like this, any such general patterns that are existing in our data, we are going to understand in the descriptive data analytics, as well as we will try to see some of the patterns like relations and the correlations we were trying to identify using descriptive analytics. Let us say if you are running a cafe, here you are seeing the temperature on the x-axis and the sales of the ice cream on the y-axis. While temperature increases, let us say sales is increasing. So here you are trying to identify the relation that exists in between the temperature and sales of ice cream. Similarly, the temperature with respect to the coffee or the tea. So it won't be like as it is. So it may have some inverse relation. Those sort of relations we are trying to identify in this descriptive data analytics. Let us say the stock price is increasing, the gold price is decreasing. So such sort of things we can clearly observe in this descriptive data analytics. Hope I'm clear with everyone. Do you have any doubts so far? Am I clear? Shall I go ahead?
So please go ahead, sir. Please go ahead.
Thank you, Dasha. Thank you, ma'am.
Others, please stop your video. Please, we request you participants, please stop your videos. Other than Tulsi, sir.
Thank you, ma'am.
Yeah, sir. Please continue.
Is my screen visible, ma'am, now?
Sir, it is visible, quite visible.
Thank you very much, ma'am. Thank you. So what are the common tasks we will be doing in descriptive data analytics is? The first one is the summarization. What summarization is, you may have your sales data in a detailed manner from various stores, let us say. If you want to understand the sales at a higher level of granularity rather than a detailed level, we will do summarization. Let us say you are having the sales information of each store with respect to the each store. That is detailed one. With respect to the city or with respect to the state or with respect to the zone, if you want to understand, that comes under the summarizations. So what you are doing here, some of the major tasks like summarization we were doing. And another important thing, we will be doing visualization. Why visualization is very much important. If you want to be a data scientist, you should know how to tell a story using a visual. You should know visual storytelling. So to better understand that, here I am bringing an example of Anscombe's quarter data sets. Are you able to see here? We were taking 4 different data sets. This is one data set, this is second data set, third one, and the fourth one. If you see the mean, standard deviation, and the correlation coefficient of all these data sets are same. If you try to play with the summary statistics of these 4 data sets, we may be fooled that all the data sets are representing about the same information. But once you try to put them as a simple scatter plot, you can clearly see that all these four are representing four different data sets. That's why there is a saying that one picture is worth than 1,000 words. So what we can do is we can describe, we can show the hidden patterns of the data by doing visualization. Along with this, we will do clustering. I'll talk more on clustering in the upcoming slides. And we will try to find the associations, like what is the likely chances of purchasing bread and butter? Those who purchased bread and what they're likely to purchase next. So such close associations, these are very much helpful in keeping the things together which are purchased together. Even you can see clearly those sort of patterns in most of the shopping malls, how they are keeping one after another. Even the way of keeping the what is this floors, why first floor is always preferred for these what do we say, the hairpins, the nail polishes, such sort of things. Why the first floor is given for kids alone, why the next floor is given for what do we say, ladies fashion things, and the top floor is given for the gents and the bed sheets and those things. Maybe you know what is the reason behind that. Yes, so there they have clearly identified the association of each floor with respect to those particular items. Yes, and similarly they will do the sequence discovery also. This is very much helpful in identifying the sequences. So let us say you want to do some book recommendation or movie recommendation. So you can do some simple sequence discovery. So part one, he has seen. So I'm suggesting part two. So like a sequence of recommendations you can generate. Yes. So at a primitive level, these are the various tasks they will be performing at a descriptive data analytics side. Whereas in diagnostic data analytics, it is completely inclined towards root cause analysis. In descriptive, you identified that something has happened. Now you are asking a query like, why this thing has happened? Let us say most of your academicians, you are taking attendance for your class. Let us say one guy is always missing on Friday. Yes. So that is the pattern you can see from the descriptive data analytics. Let us say I am putting on my calendar from Monday to Friday. I can see that present, and Friday I couldn't see that particular person. Then we were trying to do the root cause analysis on that particular day. If data exists, we can see, let us say every Friday he's doing some part-time job. Let us say every Friday, most of the movies are released. Probably he's a movie lover. So all the 4 days he's attending the classes, and the 5th day he may be going for movie. So such a root cause analysis, why that particular thing has happened, you are trying to understand using this diagnostic analytics. So here you see, here plant has, like, let us say one example I have taken, there is a burning situation in the plant. Then what you will try to do is, what are the root causes for this you are trying to understand by using some what is this, a fault tree analysis we will be calling it as. So smoking has occurred and sparks came, or some short circuit has happened, then ignition was there, or any combustible material are there, any place, any like fire out of control. So like this you are trying to understand in the diagnostic analytics. Clear? And what are all the events that are happened, which event happened first, such sequence we will be keeping, and what are the factors that are affecting on each event we are trying to understand using event and causal factor analysis. Yes. So here what we were trying to understand clearly is, what is the root cause for something has happened in our data we are trying to understand in diagnostic data analytics. And this is called predictive data analytics, where you are trying to predict the future. So let us say I'm trying to understand the behavior of a motor in a particular organization. Let us say slight vibration comes for 1 day, and apparent noise is coming on the 2nd day. Small heating up is happening on the 3rd day. 4th day, there may be a, what is this, fuse burn or something. So in my past data, I observed that these are the patterns that are frequently repeated. So in the current scenario, in today, let us say there is an apparent noise or a vibration. I'm predicting that on a 2nd day, we will get noise. On the 3rd day, you may have some temperature change at that particular place. If you are able to mitigate the problem within this is called a predictive maintenance. So before this, if you are able to have maintenance for that particular motor, you can save some money and time of the organization. Otherwise, you may get into undesirable situations. Clear? So what we were trying to do here, we were trying to understand what likely to happen in future. So here we will be applying few techniques like classification, regression, and time series analysis. One thing I would like to emphasize more here, most of the people, you know, so many tools that are available in the market, and you no need to write even code also. I'll show you some of the softwares which are very, what is this, ease in using and ease in understanding. But what you need to do is you need to understand the things which are happening behind the scenes. Clear? Let us say, maybe most of you heard about, even in the previous session, one of the resource person has talked on linear regression. Am I right?
Yes. Yes, sir.
So what we need to understand is how we were arriving to this particular, what do we say, equation. So you see, I can draw infinite many lines among these data points within this two-dimensional plane. What is my objective here? It is to draw a best fit line which can reduce the residuals among these data points. So those things we need to understand very clearly. Why? Because so many libraries that are available, just what you need to do is you need to push the data, you need to tweak some of the parameters, and you need to get the output. But you should know how do we infer the things from the output, and what kind of parameters we need to tune for improving the efficacy of the model. We need to understand thoroughly. I'll show you some of the examples, then you will understand why we need to understand the things which are happening behind the scenes. Yes. And as I pointed earlier, we were trying to understand descriptive, diagnostic, and predictive. After recommendations from the predictive, after predicting the things from the predictive data analytics, we need to tell what course of action you are going to take for mitigating the situations what you are expecting in the future. You see, we were not able to predict the severity of the corona in the phase 2. Yes, that's why we can see there is so much of human loss. Clear? So in the prescriptive analytics, if it is likely to happen this, So how many beds are required? How many medical practitioners are required? How many medical kits are required? All these things we can clearly look, or we can clearly take a decision, and we can take a course of action in prescriptive analytics. So here he has given clearly, you see, what are the proactive decisions to be made? If we are making those decisions, how much benefit we are getting, at what is the best time to take this action. Let us say you are telling this action should be taken. If it is not taken at the right time, you won't see the impact what you are expecting. Am I correct? So we should be very careful in taking the prescriptive data analytics. And these are some of the techniques, like various machine learning techniques and algorithmic inferences, various optimization techniques, and NLP vision side. Also, we will be working more on this particular prescriptive side. Let us try to understand what exactly this data analytics life cycle is, and what are all the various phases, and how we were moving forward from business understanding to the deployments or visual presentation. So the first and foremost thing is you need to understand the business. In that, you need to understand what are your main objectives, basic primary objectives. For fulfilling those objectives, how you are going to gather the information, and and you will be having a specific objective. To achieve that objective, what are all the methods that are required, appropriate methods that are required, you need to understand. Along with that, you need to tell the scope and limitation of your work. And at the end, what kind of deliverables you are going to give it to your client or giving it to the end user, you should clearly understand at this particular phase. Later, maybe in machine learning side, the resource person told that a particular abbreviation called GIGO. Maybe most of you heard about that. Computer science people heard about this. Yes? Can anyone tell me what is this? GIGO? This is like a garbage in, garbage out. So here the learning is completely a data-driven learning. So if you say 2 3s are 5, your machine will learn 2 3s are 5 only. It never say 2 3s are 6. It won't say correct. Why? Because so the learning is implicitly taken place from the data what you are pumping to your model, what you are fitting into your model. So that's why you need to understand the data thoroughly. So in this particular phase, what we are doing here, we were collecting the initial data. And if the data is not available here, what kind of other ways of acquiring the data you need to understand. And you need to understand the characteristics of the data, whether the data is available in a structured format or an unstructured format or semi-structured format, and how this data is, whether data is not in motion or whether data is in motion. If data is in motion, what kind of streaming analytics, so such sort of things you need to understand at this particular juncture. Once your data is ready, you need to prepare the data. Why? Because 80% of the time, most of the data scientists and data analysts, they were spending on data cleaning and data preparation only. Why? Because most of the real world data contains noise and inconsistencies. So as I told, garbage in, garbage out. So you should not simply fed the available data as it is. You should see whether the data is up to the quality or not. If not, what you need to do is you need to clean the data. Just for the example sake, I'm telling, date of birth is, let us say, in 1980, let us say. And years of experience, I'm saying it as 50 years. You can clearly see that from this, or the date of joining in the company is, let us say, 2000. and the experience I'm saying in the company has 50 years. So you can clearly see such inconsistencies should not present in your data. And as Sar told that you are gathering data from multiple sources, and that data you are trying to analyze. Yes, while you are gathering the data, here let us say they are following one particular date format like day, month, year. Here they are following month, day, year. Here also they are following day, month, year, but month is not numeric, that is, let us say, string. Then how you are going to bring a unified structure to the data? All these things you should take care in the data preparation side. Yes, you need to clean the data. You need to, one important thing, maybe some of the people while you are doing research and all, so the data representation plays a very, very important role. So if they have given you an image, how do we represent the image? Computer understand only zeros and ones. Yes. How we were translating this particular given data form into the zeros and ones form? Let us see if they have given you the text data, how you are representing the text data, how you are representing a given sentence as a vector. How do you compare two sentences, whether they are representing the similar sort of information or not? So here, the basic crux lies here, it is the data representation, how you are representing it. And another thing you need to understand here, sometimes you don't have that much computational capability to take the entire data set. In such scenario, what you will do, you will do some sampling techniques. Rather than taking the entire data, we will be taking some portion of the data, and we are trying to apply our analysis on that. And another important technique called exploratory data analysis. So here, what we were doing here, it is, we will do some assumptions. We'll have some hypotheses. Those hypotheses was correct or not, we will try to understand with exploratory data analysis. Let us say I'm thinking that whenever gold sales is up, that day stock sales is down, stock market is down. So what I can do is I can put what is this, a plot, a suitable appropriate plot, where the movement of gold and where the movement of stock. Here you can clearly see that when this one is moving up, this one is going down. So I can validate my hypothesis was correct or not by performing EDA at the early stages. And here you can clearly see people nowadays, they are talking about curse of dimensionality. Before talking about those jargons, if it is a structured data set looks like this. Maybe most of the computer scientists, computer science people, they know, but other people you should understand. So this is called observation or row. This one is called feature or dimension or the column or attribute. Clear? Each column is called a feature or attribute or a dimension. If you keep on increasing the dimensions, it is slightly difficult to build a model. Yes. So in such scenario, you need to identify what are all the discriminating features for my task you need to understand. Let us say, I would like to distinguish whether it is an apple or a banana. Let us say, just for the understanding sake, consider that this is a banana. Yes. So I'm taking some features like weight and the shape, the color, and the price. Let us say both apple and banana are 30 grams, let us say. And this is, let us say, circle shape, just for the understanding sake. This is like a cylindrical shape, or this is a sphere shape. and the color, assume that all the apples are in red and all the bananas are in yellow. And the price is also, let us say, this is 50 rupees per piece and this is 10 rupees per piece. Can you tell me what are the discriminating features to distinguish whether the given observation is apple or banana? Can I take the weight? Here both are same. So this is not a discriminating attribute to distinguish apple and banana. So I can't take this. Whereas the shape, the color, and the price, these are clearly showing some discrimination in between these two. So I can determine these are the important attributes for my particular task. Hope all of you are following. Am I making sense or?
Yes, sir. Yes, sir.
Yeah, thank you. Once you are ready, then you can build a model. So here, model building is what we were doing here. They will be giving you some data like this. I hope you're able to see my screen. They will be giving you some data like this. Out of this,
Sir, please share the screen. Share the screen. Okay, okay, okay.
is it visible, ma'am?
No.
1 minute.
Yes, sir. It is visible now.
Thank you, ma'am.
Okay, sir.
So here you can clearly see this is my data set, and what I need to do is I need to find an approximation function. It is in a simpler manner. You will be giving the inputs like this. This is x1, x2, x3, and x4, and this is my target, let us say y. So what you are trying to do here, model in terms of model, is you are trying to define y in terms of x. Let us say if I'm giving like this. This is x1 and this is x2 and this is y. You can clearly see that y is in terms of x and y as x1 plus x2. So we were trying to find or establish such a relation with y and x using machine learning. Once you build the model, you need to assess the model, whether your model was perfectly working or not. Yes. Why I'm telling that, you may be working on the data which is a past data. Maybe I'll show you. Is my screen visible?
No, sir.
1 minute. Is it visible, ma'am, now?
Yes, sir.
Yeah. You see, this is a case study we have taken for Hyundai people. Here I created a model and I need to diagnose my model, whether it was correct or not. Here I have taken few parameters like temperature, current, and acceleration, and I am making a predictive model. You see, simple. I found some weights and I am multiplying with the variables like x1, x2, and x3. If it reaches to a specific threshold, it will fire up and some accident may happen. So you should be very careful. Until and unless it is reaching to the threshold, you need to take an action. So this is my offline model. So whatever the testing I am doing, whatever the evaluation I am doing on my offline data, but while you are deploying it, you should see whether your model, whatever you have made it on the offline data, whether it is working fine on the real-time data or not, you need to check. If it is not working as you expected, you need to tune the model to fit it into the real time. So we should be very careful while we were applying data analytics in the real world. Why? Because even we have seen some of the use cases, like people were saying that they did some, what do we say? They created a model for some company, one particular team. They have created a model and they told that this is the better recommender model. But in the real time, it didn't work well as they expected. It leads to some $1 million loss. So we should be very careful while we were playing with the data analytics. Once you build the model and once you decided that your model is working fine, then you need to review the model and you can give it to the end user. You should be very careful while you are submitting your deliverable to the end user. Depending upon their level of understanding, you need to submit your result in such a manner. Let us say they don't know anything about the working mechanism of computers and all. Then you simply give them with a dashboard kind of thing. Yes, maybe some of you heard about these things, like making a dashboard and all. Is my screen visible? Ma'am, is it visible, ma'am? Can anyone kindly
Sir, it is visible. It is
Yeah.
visible.
Yeah, you see, it
Please
is.
continue.
It is, thank you, ma'am. It is a very straightforward, very simpler thing called Gapminder. So here on the x-axis, I'm having the income. On the y-axis, I'm having the life expectancy in years. You see, the beauty of this particular dashboard is what you are doing on a two-dimensional plane. You are representing 4 dimensions. You see, size is the population and the color is the world regions. Even you can you are telling the income levels also. This is income level 1, income level 2, income level 3, and income level 4. Yes, let us try to see how the things are happening from 1800 to today.
Participants, please mute yourself. Participants, please mute yourself.
Are you able to see?
Srikant ji, please mute yourself. Srikant ji, please mute yourself. Srikant ji ke. Okay, sir, continue, please. Sorry for the interruption.
No worries. Thank you. You can clearly see how the things are moving.
Srikant sir, please mute. Please check. Please mute.
You can see how the movement of India. Able to see?
Yes, sir, we are able to see.
Similarly, you can see babies per woman with respect to the year, let us say. In 1800, you can see some of the regions, even they are really looking for 5 to 6 babies per woman. Now you see how the things are going on. Let us say, whenever I'm focusing my mouse, it will tell which country or which region I am focusing. You see how nicely he is conveying the entire story. So there are really beautiful tools that are available, like Tableau or even Power BI. Through that, we can create nice dashboards and all. So this is the way you can tell the end user what you are going to tell. Let us try to understand what are the various tools that are available to apply data analytics. Here I have given you some of the important tools. There are other tools also. If you ask me what is the tool you will recommend for doing data science and data analytics, there is no other doubt. I will say that you can go ahead for Python. Let us say if you are not good at some coding and scripting, then better you go for R. If you have a mid-level or a surface level coding capability, then you can go for R. Both are open source. You can work with, if you are having a simple workstation, that is enough. Even for Python and R also, there are some online availability. You no need to install. R server is there. Directly you can do that thing from your web browser. And similarly, for doing any data science or data analytics and machine learning experiments, you no need to install even Python. Google came up with their own proprietary called Google Collaboratory. This one. Are you able to see? It looks like this.
Yes.
It looks like this. Maybe most of you are aware of this,
Yes,
but
sir.
for non-computer science people, I'm giving more stress. So for playing with this, you need only what do we say? A Gmail account is enough. It comes with various other facilities. Let us say someone else is having some code in the GitHub repo. What you can do is you can directly pull their data from there to here. Let us say here I have some notebooks, let us say machine learning with Python, let us say. From this, you can, this particular thing you can copy and you can directly get that particular workbook from here itself. Yes. So these are all the various things you can, 1 minute. So with Colab also you can try, you no need to install Python on your machine. And the next one, even with the simple Excel also, you can get better insights. There are various real-time collaboration, and this is one of the new feature. If your data is with a picture, you can add that photo directly, and that photo table can be converted as an Excel, what do we say, spreadsheet, a tabular format. Yes. So some of the big giants still they were using Excel for getting better insights. As just now I told that Tableau is one of the good tool for doing business intelligence and creating dashboards and all. Just now I have shown you one dashboard called Gapminder. Such sort of what do we say, dashboards you can create with the Tableau. And if you are an academician and you are having your official email ID with your ID card, you can get 1 year license, a free license for what is this, Tableau. Every year you can what do we say, renew it. And another thing, RapidMiner, this is pretty straightforward tool, like it is like a drag and drop tool. You no need to write too much code. RapidMiner as well as another thing called Nine. These two are similar sort of tools. You can perform data analytics, reporting, integration. This completely comes with a GUI based framework. Even Orange also the same tool. Let us say at a primitive level, if you want to explore, another important tool is there for machine learning enthusiasts. You can use Weka. Maybe some of you people heard about that. It is a very simple thing. It comes with it comes as a jar file. I'll show you how it looks like. It is very, very non-computer science people usually they will feel like I don't know coding and all. People are writing so much. able to see? This is the simple tool. It was written in Java. So you can make use of this. And the other tools, like you can use Power BI from Microsoft. There also you can have the facility to create dashboards, reports, and so forth. And afternoon, probably Amrit sir is going to talk on this particular thing, Spark, if you want to do cluster computing and in-memory analytics and some real-time processing, such sort of thing. I'll recommend you to go ahead with the Spark. And another alternative for a Tableau called ClickQ, whatever the business intelligence and reporting form of things, whatever you are doing with a Tableau, the same stuff you can do with ClickQ also. And for data ingestion and data integration, like extract, transform, load, such sort of operations, you are having Talent, you can make use of this. And mornings are talked about some searching and analyzing and visualizing capabilities regarding one of the tool. Similarly, here also you are having one thing called Splunk. Through Splunk also you can do searching, analyzing, and visualization. Now people are getting to a confusion state, like Tulsi talked about so many tools, and each tool is doing some specific action. Specific activity. So which tool I need to confine? So this particular visual can summarize which tool may be better. I recommend to go ahead with the Python or R. If you want to do individual things, you can try with individual tools like this. So on the first row, you can see Python for data collection and all the required packages I have given here for data exploration, for data preparation and modeling like SQL, and here in R it is Carrot. There you can play with pandas in Python. Here you can play with the deep layer or data table. And for reporting and all, you can play with Jupyter. The Jupyter environment only you can see in Colab. Yes. Even R you will be having a Shiny. Yes. So you should be very careful in choosing the tool. So I recommend you guys to go ahead with Python. I'll show you a simple thing in Kaggle. Sorry, 1 minute. So this is the place where most of the data analytics competitions will happen. One is Kaggle, driven data, Coda Lab, like this various other things. I would recommend you guys to go ahead with the Kaggle and Analytics Vidya. So there they will be hosting so many competitions. Here you can see these are the competitions from the Kaggle. So on the left hand side, you can see various items you can select and you can see. So here I'm clicking on competitions. So here I clicked on one particular competition called house prices. So here they will be giving you complete information about the competition, what that competition is meant for, how much data they are giving, and what are all the files they are giving, whether it is having a prize money or not, whether this particular thing will improve your practical skills or not. All these things they will be giving the description. And the next they will be giving the information about the data, what kind of files they are giving and what each file consists of and the size of each file. And another important thing you should understand here, on the bottom of that, you'll be having a link to download the data set. Here I'll be showing you. This is my Colab environment. What I'm doing here, I'm directly extracting the data from Kaggle to my Colab. I'm working here in my Colab. Once it is done, I am going to upload the submission into the Kaggle. So here the competition is, you need to predict the house price of the houses given in this particular competition. So what are the fields that are there? So these are the 79 attributes you are having to predict the sales price of the house. This is my target, and these are my predictors. I need to use these things for predicting that. So there they will be giving you two data sets. One is trained data set and another one is test data set. So what you are doing here, maybe in ML, they might have explained clearly. You will be trying to identify an equation which can predict the sales price of the houses in the training data. From that, what you are doing from the test data, whatever the predictors, the regressor values you are having, those things you are substituting in the equation, and you will be trying to get the value of the sales price. Once you got the sales price, you will be having another file called submission file. In the submission file, you will be having two things. The ID of the house and the sales price of the house. What you need to do is you need to paste the predicted price for that particular ID. This ID related information like the number of bedrooms, the number of bathrooms, whether it is in a specific zone or not, whether it is approachable to the hospitals or not, such information will be given in the test.csv file, test file. Yes, once you finished the task, let us say here I have taken the data. This is the way you can create a directory. And another important thing here, you need to create your what do you say? You need to go to home. Here, once you have successfully created your Kaggle account, you click on this and go to your profile and click on account. And here you will be having API. If you simply click create new API, it comes with a JSON file. Are you able to see? Kaggle.json.
Yes, sir.
This one. So I'll be opening and showing it to you. So here it will tell what is your username and what is the key. This key should not be shared with anyone. Why? Because with that key only you are pulling the data into your Colab environment. So here, once the JSON file is ready, what I am doing? 1 minute. I'll be uploading my JSON Kaggle.json here. Now you see, once it was loaded successfully, JSON will come here. Able to see? Now what I am doing?
Yes, sir.
I'm giving the permissions and now I am downloading the data. Are you able to see the corresponding data was downloaded here? If you refresh, you can clearly see the data will come here. What happened is I have directly installed the Kaggle through pip, and I have created a directory. In that, I have copied the Kaggle.json, which consists of my API keys, and I gave privileged read write permissions directly using this particular command. Then I am directly downloading this from the Kaggle. Here you can see in competitions. Let us say this is another data set, another competition about the Titanic survival prediction. If you see at the bottom of the data set, you will be having one thing, this one. So what you need to do is just you need to copy, paste that thing in this. That one only I did here. Kaggle competitions download, copy this. What is this? Titanic. So it was a zip file. Let me unzip it. And you can see if it is not coming here, just you need to refresh the folder icon here. Then you can see all the files, test file, this train file and the submission file. Once you did data preparation and data imputation and various other things, feature engineering and all, maybe Nagarajan sir has taken through all these things in his session, I think, one ML experiment. Once you are done, then you will write your submission file like this. I'll share the notebook with the I got one file. That file was Kaggle, this thing. Go to my submissions. Yes, this is my submission for the FDP. Yesterday, I tried to write a simple submission. What I see in my data set was female and children are survived better. So with the blind assumption, wherever the gender is female and the age is less, I put 1, and other things I put 0. With that blind assumption, you can clearly see what is my score. Are you able to see? I am in 8,579 position out of 13,000 entries were there. Yes, similar. This is for classification. Similarly, this is another competition for regression, for house price prediction. Here also I did few submissions. You can see the lead board where I am. Able to see, this is I'm in 317 out of some 8,000 or 9,000 people. So why I'm showing this, to boost the skill sets of data analytics. What you can do is you can register for any competitions in Kaggle, and you can do your submissions, and you can see how active you are in that particular field is. And if you want, if you are having some time, probably the ML part, another speaker has covered it. Yes, ma'am.
Sir. Yes, sir, it was covered.
If you want the slides, even I can give it to you. So
Please share them to convener, sir. Please share.
I'll share, ma. This is very useful for the non-computer science people. If they want to do any experiment using Veka, the corresponding link also I have given here. Which one they need to choose? Just they need to open Veka, click on Explorer, and open a file. It will be there in the data sets. Let us say I'm taking about one particular data set on house, let us say. I don't have this. Yeah. Let us say this data set I have taken. So this is the information about various purchasal patterns of the customers. Just I am doing clustering. Let us say I no need to do anything. Just I need to choose that particular thing. The number of clusters, let us say 5. I'm not doing anything, just done. Model was done, and you can see the output also. But you need to interpret the output in a better way. Yes. So the corresponding thing, it was clearly given in my blog. You can explore it. I'll be sharing that thing in the chart window. Shall I share it, ma'am, in the chart? Is it fine?
Please, please. That would be helpful, sir. Please share.
This is the website about the Veka for the newbies who wanna do some machine learning related stuff. You can work on this. The complete explanation we have given, what are the data sets that are required, and a tutorial on that, like how do you do clustering or classification, pre-processing, all this stuff, time series analysis. Yes, that's all from my end. If you're having any doubts, you can ask.
Participants, use the chat box and you can raise the questions. Any queries, please, you can.
This is the competitions related thing. And this is the place where we were playing with Colab. Even this notebook also I can share, I think.
Sir, here's a question, sir. Please
Yes.
open the chat box. No?
I'll see.
Yes, yes, sir.
No, sir, I don't have any YouTube channel, ma. Like the materials and all will be shared in the blog itself. Even from my GitHub repo also you can get that one. GitHub repo, I will make it public, ma'am. That one, all the machine learning experiments, you can take it.
Thank you so much, sir.
This
Be
particular,
more helpful.
yes, ma'am, I will do that.
We are lucky to have you here, sir.
No, ma'am, this one I also learned the same way, gathered from here and there. This is not my proprietary, no.
Okay.
So this is the place, I'll make this thing public. You can access it. 1 minute, machine learning with Python.
Sir, here is another question, sir.
Ma'am, please.
Park sir has asked why to transfer Kaggle API to Google Colab while
You-
ML can do.
Yeah, in Kaggle also you can do. In Kaggle also you can directly do. That's
No,
also good.
No, his question. Please read his question in the chat box.
That only you can do it in Kaggle, but even here also you can do TPU and all. There also you are having TPU and all.
Okay, thank you, sir.
Just I wanna why, because most of the people they may be comfortable here. Collab. Yes, ma'am. It's public.
Good morning, sir. This is Lakshmikant Reddy from AI Department of Anurag University.
Sir, tell me.
Sir, I
Sir.
just want to know, in order to import data, we make exclusive use of Kaggle data set. So other
Right.
than Kaggle, is there any other areas from where we can download the
Data sets you are asking,
Yeah.
sir.
Yeah.
UCI repository, sir.
UCR?
Maybe. Mm,
Okay, sir. Thank you.
very good. This one, sir. UCI machine learning repository.
Thank you, sir.
Thank you, sir.
Ravi garu, able to see?
Yes, sir, we are able to see.
Even this one directly we can import from the collaboratory. Let us say this is my collab. I can directly give my GitHub repo. Able to see
Yes,
the
sir.
audience.
Yes, sir.
Whatever the experiment I need from my repo, you can directly click and see. Let us say just I'm directly getting from the GitHub repo itself.
Yes, sir.
Audience, if no more queries, ma'am, can you wind up the session?
Sure, sir. Sure. No more queries, sir. They have asked as many as possible. Session was really fruitful. We are lucky to have you here.
Thank you very much.
With your
Thanks for the
expertise-
opportunity.
With your expertise and as certified master trainer, you have shown what you are, sir. Thank you so much.
Thank you. Thank
Session
you.
was so much informative. We're lucky to have you.
Thank
We'll hope many more things to come forward from your side. We expect
Sure, ma'am.
few more sessions.
If any hands-on, the people may be more interesting.
Yeah, sir. We will definitely put forward, sir.
Yeah. Ravi garu, I will share my.
Participants are also really happy, sir. You're facing many queries today.
Thank you, ma'am. Ravi garu, you can drop your email. I will respond if you have any query. Anand sir, ma'am, Anand sir is there?
Sir, Anand sir is quite busy with his class.
Yeah. Okay, ma'am.
You can wind up the session, sir. We expect Amritpal sir to join by 1:30.
I'll inform, ma'am.
Huh?
I'll inform the
Because
same.
we'll continue the
Sure.
valedictory after it.
Sure, ma'am. I'll
Huh?
inform. 1:30 to
Uh,
3, no, ma'am. Okay.
1:30 to 3, sir.
Sure, sure, ma'am.
Sir, thank you, sir.
Thank you, ma'am. Thank you, participants. Thanks for your time. Thanks for the opportunity, ma'am. See you. Bye-bye.
Bye-bye, sir. Participants, please join by 1:30.
Good afternoon, participants. Good afternoon, sir. We are audible. Amritpal, sir.
Yes, ma'am, you are audible. Good afternoon, ma'am.
Good afternoon, sir. Sir, you can start this session, sir.
All right.
Thank you, sir.
Is my screen visible, ma'am? Please confirm.
Yes, sir. Yes, sir. Not visible, sir.
Not visible.
Stop screen. What? Now is it visible, sir?
Visible.
Yes, sir.
All right. Thank you, ma'am.
Thank you. Sir.
Good afternoon, participants, and good afternoon to all. So, this in this particular session, I'm going to cover distributed processing, Spark context, Spark components, different components of the Spark. What is RDD? What is the concept of materialization? Basic Spark applications, and what are different key value operations in context of Spark streaming, and incremental data clustering. So this is the outline of like what we are going to discuss now. So first of all, I'll start with the distributed processing, which is basically how different machines are grouped together to form a cluster, and so that they can achieve, they can be given some task, and that task they are going to perform in a distributed manner. So now a cluster is basically a group of machine, and we can say it's a pool of resources, and many machines, they are working together, and there need to be some access medium with the help of which we can access those machines, right? So the question is, does a group of machine is enough? So that is not enough just by combining those machines together. We need a framework to coordinate the work among different machines. How the coordination among different machines is going to happen, that is required. Now, Spark is basically a tool to manage the work among different machines. So if you have a cluster to which you can give some task, in that case, Spark is going to manage the cluster, right? So that the task which is going to be given to different machines, that can be controlled, and that can be what input is going to be given, what is the output, everything can be handled using Spark. Now, as I said in my previous talk, like we were having this Google file system first. This came into picture. People at Google, they tried to join the different commodity hardware, and they tried to come up with a file system so that they can store the data over a different system, right? So now it was a master-slave architecture, basically. It was a master-slave architecture. So what is a master is going to do? First, the overall data, right? There is going to be a Google file system master. The overall data was divided into different chunks. So each file is actually divided into different parts, and those parts are saved. Those chunks are saved over different units or different machines, right? And there was a chunk server, GFS chunk server, who is actually taking care of these partitioned data files. Then there was a concept of like whenever some user wants to get some data, so those chunks are going to be fetched from different system, and it seems like that the overall data is available at one place. So all of those things are managed by GFS file system. Now we are using like our laptops. There we have our hard disk. Now we don't know where actually the data is stored. For example, you have copied one particular movie on the drive, right? How you are able to access that? There is a full hierarchy of like you go to that one particular drive, into that subfolders are there, right? So this interactive sort of interface is given, with the help of which you can directly access that movie. Now, if the movie is actually divided over different machines, then this GFS was there to provide the that kind of interface so that you can access the movie like it is at one place, right? So this is about GFS. So then GFS was in 2003, then Google MapReduce was in 2004, and then Apache Hadoop came along with HDFS, and all GFS got modified as it is having same features are repeated in HDFS. So 2006 we have HDFS, and then because of the limitation of MapReduce, it requires all the input outputs to be done through the disk, and all results, intermediary results, were getting stored over the disk itself. So that is why there was an introduction of Apache Spark in 2014, right? And it uses memory to store the data. Now, what I'm going to focus on, how it uses memory to handle large amount of data. That concept we need to understand first. All right. Now, Spark uses Java, Scala, and Python. All three are available with this Spark. Now, native to Hadoop system is Java. So Spark can be programmed in Java. So most of the scripts which you will see along with which comes with Hadoop setup are in Java, right? So you have Java classes over there. Now, Scala is there. Scala allows parallel programming to be abstract. Like if you want to change in the structure of the Spark, right? If you want to do core programming for Spark, for resource management, right? Then you have to learn Scala, right? Just in that case, if you want to work over, if you want to improve the functionality of this Spark, in that case, basically you must go for Scala. And PySpark is it's a Python library basically, and you can actually code in Python, right? Because most of the machine learning engineers are working, they're working using Python, right? And it provides a similar interface basically. And PySpark, PySpark is going to provide you a sufficient library so that you can apply data analytics approaches over there, right? But it is not going to achieve same efficiency as compared to Scala, right? Because Scala is the you can directly work on the Spark interface. But still, if you want to do analysis, you can go with PySpark, and we will be dealing with PySpark. Now, one concept about Spark which we need to understand is the Spark context, right? And this is the most important component when you are coding with Spark for Spark, right? So it is the piece that connects our software, and it is going to control the whole cluster. Right? Full cluster is actually controlled by Spark context. And I can say that when you want to access one particular cluster, how you are going to logically access that cluster, right? Logically, how you are going to access that cluster by using Spark context. Whenever you are going to execute any job, so first you need to interact with the cluster, and that virtual interaction, that virtual availability of the cluster is going to be ensured by the Spark context, right? So to control nodes is controlling of the nodes or objects or subtask, right? Everything will be done using Spark context. How you can create a Spark context? You can simply create, there is a this syntax is there, with the help of which you can simply create an object SC using Spark context, right? And in one particular notebook, I have written notebook because we will be using Colab to code for it. Then in one notebook, we can have one Spark context, meaning that when you are submitting a job, you can have one Spark context, right? For a given cluster. So this is about Spark context. We will see it, how it is going to work. We'll code for it. And then there is another concept, which is resilient distributed data set. So in short form, it is known as RDD. So what is the meaning of RDD? Actually, Spark creates abstraction for the data access. It is not going to say when you load when you want to store data in a variable, it is not always that it is going to take that variable in the memory, right? It is going to provide abstraction to define distributed data on different machines. So, for example, like we have different participants over here, and as I've taken the example that you have different data, different laptops, and one single file is actually distributed over your laptops. Now, how we can, like what sort of abstraction we are going to have, that if you want to access that file, this RDD is going to make sure that we should not be bothered about where that file is actually stored. We are directly going to create an object for that file. And over that object, we can apply operations, whatever we want to do with that file. So that abstraction is ensured by the RDD, right? For example, a list whose elements are distributed over several computers, right? So for example, you have a very large list, right? List of say n numbers where n is very large. And how you are going to access this list. So you can create an object of RDD over this list, right? And this list may be divided over different computers. And whenever you are going to apply any operation over this RDD, the operation will get reflected over the partition of this particular list, which are actually not stored over different systems, right? So that sort of accessibility is provided by RDD, right? And this is the main data structure in Spark. This RDD is the main data structure of the Spark. Now, when an RDD forms, the list can be manipulated only through RDD specific commands. So whenever we are going to create an RDD over a list, we need to apply some commands, right? Like RDD command only. Based on that only we can access the list. Now, RDD can be created from a list on the master node from a file. So we need the data to be in a list so that we can create an RDD. RDD can be translated back to local list using command collect. So there is going to be a command collect with the help of which you can actually create an RDD, convert an RDD into a list, right? Let us see an example. So here is the example. Don't worry, I will provide this code to you. Let us just discuss for some time. So we have a list, right, which is 0, 1, 2, right? With the help of this parallelize function, we are going to create an RDD, right, over this list. This list is simply like a Python list only, list data structure. Now, if we want to perform some operation over this, now this RDD is a reference to this list. It is not containing the data which is there in the list. List is actually stored where it is, right? It is not storing the data, but it is keeping a reference to this particular list. Now, for example, if we are going to apply a map and reduce function, this map reduce and this lambda function again from Python itself, right? In that case, so this function is like this. We are going to take each element, multiply that element with the same element. That is what map function does. It applies the operation over all the elements of the iterable. So we have this x, right? Multiply by x. So this is done, right? And then what reduce function is doing, it is doing the addition of all the elements, right? So it will result in 0 multiplied by 0 plus 1 multiplied by 1 plus 2 multiplied by 2, right? And this operation is going to be applied. The answer is going to be like this. But this answer is not going to be realized until we like sort of print this RDD, until we collect the data from this RDD, right? So the example, when we are going to get the answer, get the result, when we are going to apply the collect. And so in this example, what we are doing, we are just simply multiplying the elements and creating another list. So map is going to result in another list in which we are applying 0 multiplied by 0, comma 1 multiplied by 1, 2 multiplied by 2, right? So that is getting created in another RDD. That is getting passed to another RDD. Now this, when we run this function a.collect, at that time, the final answer is getting generated, right? Now, this is about collect function, map function, lambda function, and how you can actually use these functions. All these functions are basic Python functions, right? Which are available with not only in Spark, it is available with your Python also, right? Now, this collect function is actually fetching. It's actually when you are going to call this function, at that time only all the calculations are going to happen and the result will get generated, right? Now, checking the start of an RDD. So for example, we want to create an RDD in which I'm going to store 10,000 numbers. In this RDD, I'm going to store 10,000 numbers. Then how should I approach to this? See, B is equal to SC parallelize range. When I use this range function, so it is going to create a number starting from 0 to 4 timelines, right? So it is going to generate numbers like this. So all these numbers are getting generated in form of a list, and that is actually passed to this B, which is an RDD, right? So now if I want to access first few elements of this RDD, then we can execute this function, right? If I want to get the first 5 elements, then I can execute this function. So what I'm trying to do here is to familiarize you with some basic functions in context of applying operation, fetching values from RDD. Now, there is a sample function also with the help of which you can take a sample from the given RDD, right? And this collect function, as we discussed, is actually the final. When you execute this function, then only the final execution of the RDD is going to take place. Now, what are the different? I will come back to this code again one more time. What are the different components of the Spark, right? How execution in Spark takes place. So first of all, as I said, the main component is Spark context, and this is it is a part of driver program, and this is the device where you are going to provide your script, right? In this only you are going to provide your the whatever the program you want to execute, that is provided through here, and we call it a driver program. And Spark context is actually making this particular cluster accessible to your script, right? So now Spark driver, it is a separate process to execute user application, and Spark driver is going to create a Spark context to schedule the jobs and negotiate with the cluster manager. So there is a cluster manager which is actually going to manage and allocate the resources for a given task, right? So this is the cluster manager. And then we have different nodes, node 1, node 2, up to node n. These are the nodes which are having these are the different, you can say, slave nodes also, right? So these are the nodes where the actual processing is going to happen, right? So the different tasks will be given to each node, and these nodes are going to process the task and going give back the result, right? Executor runs the task scheduled by the driver, store computation results in memory, right? And interact with storage system, right? So the data is actually available with these systems. Data need to be available with these systems, and these systems are going to process and then going to generate. You can actually map again the same problem of counting the words, word count program. You can simply map it over here. So at node, you are actually doing the counting, and here at a central system, you can sum them, and then finally you can get the final sum for each word, right? Now, another view of understanding is that we have a cluster manager, then you have user code, Spark session, that is the driver process, it is there, and it is communicating with the executors, and executors are the one who are actually doing the processing, right? So these are the different Spark components which are there. Then how Spark is actually going to manage this, right? How it is managed. So Spark context is the abstraction that encapsulate the cluster driver. So it is going to encapsulate everything, right? So the application does not have to bother about how many work nodes are there, how many executors are there, and how the resources are getting allocated. So everything will be done by the Spark program. And Spark, these worker nodes manage resources on the single machine. So these are the different machines or different laptops which are working, right? So these machines are going to manage their own resources, not more than that, and they are actually going to perform that final task. Then these worker nodes are going to communicate with the cluster manager only, right? And cluster manager is there to manage the resources. All right. So all these cache memory is the local cache memory available to each worker node, right? They are going to do their own task. Now, one very important concept in context of Spark is materialization, right? Why Spark is faster, right? Why Spark is faster? So that the answer to that question is this materialization. And how it is actually, how we can understand is that we don't always need to store intermediary result, right? We don't have to store the results always. So if you go with the conventional way of programming, what is there in that way? So when like each step, whenever we are doing any intermediary calculation, we are storing the result. But in context of Spark, what is there? It comes up with a plan rather than the intermediary calculations, right? Now consider an RDD1 and you applied some operation and you applied map operation and you have created RDD2 with that, right? So for example, it's a list and you have calculated the like you have multiplied all elements of this list with the element, and then you came up with a new list which is going to be looking like this, right? Now, if we deal with the conventional way of programming, so this is one list, another list is going to be created like this, and that will also be stored in the memory, right? And then we want to find out the sum of all of these numbers that comes as 14, and this also you are going to store in the memory, right? So we will put some loop over here, and then finally we will generate the result, right? Now, here, like what is the concept of materialization is that we are not going to, like the language is like this, we are not going to materialize this particular RDD, right? What do we mean by that? We are not going to create some data structure like this, which is going, a list, which is going to store 149. It is going to be rather in form of a plan only, right? It's just a plan that after this, I need to perform this operation. And after this, I need to perform this operation, right? It is going to be in form of a plan, right? And the RDD relationship between RDD, suppose this is RDD1 and this is RDD2, it is going to be in terms of, like we will say like this, RDD1, RDD2 is a lineage, right? There is a direct lineage between these two RDD. Meaning, if you don't want to produce this result, again, you want to perform some other operation, you will come up with another RDD, RDD3, and which is going to store some results, right? RDD2 can be consumed as it is being generated. It is actually not generated, but you can consume that it is generated, right? What I mean by that, we don't have to materialize it, right? The word is we don't have to materialize it, meaning we don't have to store it in the memory. When we don't have to store it in the memory, it means that we are going to save some storage, right? When we don't have to store it. So when we store our data in RDDs, the data is actually not going to be materialized, meaning that we are not storing data in the main memory, right? We are just keeping reference to the data. We are just keeping reference to the operations which we want to perform over the data, right? Not really performing those operations, right? So now you can consider it like this. So we start with some RDD, right? So this is our parent RDD, right? And then again, it is a reference to the data. How we created RDD? The RDD is by default referring to the data which is stored over different systems, right? And then we have this RDD1, then we apply some operations. And then we come to RDD2, RDD3, RDD4, RDD5. Now, if you consider the same in context of a normal programming. So you have one list, you apply operation over the list, you come up with another list that is also stored in the memory. Then continuously you are creating data structures and you are storing them in the main memory and you are filling the memory, right? Now, what we call the operations over these RDDs, we call them transformation. It means only like it is going to be just in form of a plan, only the, like how these RDDs are looking, that is getting changed, right? Nothing else. So only like what is getting changed over here, how the transformation from each RDD is happening, right? So we have RDD1 over here up to this particular RDD. The transformation will happen. Finally, when we need the result, meaning the language used is action. When we want to perform action, the action is like this, collect, meaning we want to generate the result. At that time only, the actual execution over this RDDs is going to take place, right? So it means while we are applying the operations, nothing is actually done. It is in form of plan. And then once the plan need to be executed, meaning the actions need to be performed, meaning the results need to be generated, at that time only everything is getting done. Now, you will say that, okay, same thing is actually done, but at a later point of time. The answer is no, actually. These RDDs, once this lineage is actually developed, what is going to happen? These operations, whatever the operations are getting performed, they are going to be optimized. The operations are going to be optimized in such a way that it requires minimum memory, right? So the operations which are like, when we say like it is happening over here, that we want to sum, right? So we want to multiply these numbers and sum them together, and then we keep one sum only in the memory instead of creating another list, right? Here again, that sum is getting added with 3 multiplied by 3. Again, we are keeping one variable in the memory instead of creating a list, right? So the operations, like whatever the operations are need to be performed, they are first in form of a plan. And once the action is executed, meaning the results are required, at that time only the execution takes place, and that is in an optimized way, right? And it will make minimum use of the memory, right? So transformation create new RDDs by transforming from an existing RDD. Action computes and write value to the driver program. So final value is actually done, is actually calculated when an action is performed. An example of an action is collect, right? Now some terms which we need to understand. Job. So a job is a piece of code which reads some input from HDFS or local system and performs some computation on the data and writes the output back to the like memory. And then there is another term which is stages. Jobs are divided into different stages, right? And stages are classified as map, reduce stages. Okay, so we are going to have some stages which are map stages, another reduce stages. What do we mean by map? Meaning whatever the operation is getting performed, it is performed over complete data. Reduce, when we are reducing the result, it means that we are generating one single output, right? Now stages are divided based on computation boundaries. All computations cannot be updated in a single stage. We cannot make that. We are going to create one job. Inside one job, there are different stages. And then there are tasks. Each stage has some task, right? So we have job, hierarchy is like this. We have job, then we have stages, and inside one stage, we have different tasks, right? Now, there is one direct acyclic graph in the present context, right? So there is going to be a graph is going to be created, a direct acyclic graph is going to be created, and that graph will map through each task, right? In which way the tasks can be executed, right? What are the, which one are the dependent tasks and which are the independent tasks? So independent tasks can be performed in parallel, right? And dependent tasks need to be performed in a linear manner, right? So executor, the process responsible for executing the task. Master is the driver program, and then slave machines are the executor programmers. Now consider this. Now we are going to generate one graph, and everything can be like how it can be done. Suppose there is one, first we need to create one RDD, right? And apply some map operation over that RDD, right? It means that we are working over one particular file, and over that file we are applying a map operation. Simply, for example, you have a list, you are applying some operation over all the elements of the list. Then again, you are applying some operation, right? And then again, you are filtering some out. You are just selecting few, right? So you can see when we have a physical plan for this, again, this is a direct acyclic graph. So in this case, you can say all these stages, we can say that they can be done in parallel, right? Because some operation you are applying over each element, right? So when like finding a square of a number in a list does not depend on other numbers, right? So that is stage one. So you can see this stage can be performed, right? But when you shuffle, right, meaning that you are going to apply some crossover operations, right? In that case, we need the result. So that is a stage two. So overall job is going to be divided into different stages, further, which is going to be divided into different tasks, right? And this plan is going to be generated, right? This plan is going to be generated. Once we have the plan, Spark is automatically going to optimize this plan and come up with like a with the result in a very fast manner, right? So we need to have these terms RDD, RDD graph, Spark context, right? Executor, partitions. If we know that, then we can proceed. Now, what are the different RDD commands? We can create an RDD, we can transform the RDD, we can take some actions over the RDD, right? So how the Spark context is going to handle all these queries? So one RDD, say RDD1, this particular RDD1, it is having reference to, say, over 3 computers, right? And Spark context is going to take care of that. So one RDD is there, which is suppose referring to a file, and that file is actually distributed over 3 different machines, right? So this RDD will have reference to all of them. Now, whenever you are going to perform any operation over this RDD1, meaning the transformation, that transformation will get reflected over here. Again, in form of a plan. Nothing is happening, only everything is in form of a plan, right? In the same way, we can have RDD2, right? So now whenever some driver program is going to be submitted, it will check for that which particular RDD it needs to get. And then the Spark context will fetch those RDDs, will make reference to those RDDs, and then the transformation will start, right? Now, this part, some basic RDD commands. So for example, this one is parallelize, so that with the help of which we can actually create an RDD, right? Parallelize command, we are going to pass one list over here, right? And then collects. Collect is like we are going to get the result. RDD contents in a distributed is distributed among all the executor. Collect is the inverse of parallelize. So parallelize is actually parallelizing the contents, and collect is collecting them back and returning it as a list. So it means that whenever you are going to collect the data, it means that something is ending. There is an end. We don't want to perform any more operation. We want to get the result, right? So here the plan ends. And then there is map. So map is whenever you are going to apply map function, it means that you want to execute, or you want to run, or you want to say like apply some operation over all the elements of RDD, right? And then when there is a reduce means again you want to reduce the output of the map, right? And you want to come up with some result, right? When we say reduce, okay? So it is going to again take input from the mapper part, and it is going to reduce them in one value, right? Now, there is like, I want to show you that this code is there. I'm going to share this code with you, but let me just explain this code, and then we will move to the coding part. So here, this is how we create a Spark context actually. And this number here, %d, we have given, this is varying, right? So I'm taking it in the range of 1 to 10, right? So now there is some task which need to be performed. You can see over here, we are parallelizing these many numbers and then reducing, right? And finding the sum, right, of two numbers. So now what we want to achieve with this sort of experiment, we want to see that how, when we are increasing the number of machines, right, number of executors, right, or number of the workers, then how the time is getting reduced, So in the first case, because this output is printed based on this particular loop, right? So now when we say that, this particular loop, okay? So when we say that the execution is done first time, right, and we have number of workers, say one worker only, so the time which this particular task is taking is this much, right? And when we have two workers, then it is taking this much amount of time. When we have three workers, it is taking this much amount of time. But this reduction in the time is not there after that, right? Even after second, there is no further reduction. The values are quite similar. In the first case, we got the amount of time, got reduced by half. Then the pattern is not same for the, even we are increasing the number of computers. So it is not true that keep on increasing the number of computers, we will reduce the amount of time which the task is actually taking, right? So it is not possible. Not possible in the sense the other complexities will come into picture, right? So this we need to take care of, that how many executors we are going to set. All right. So till this time, what you should be able to understand, first thing is this, that we cannot consider that by increasing the resources, the time is going to be increased in a very much linear manner. It is not there. Another one is that what are these different terms like driver program, RDDs, Spark context, workers, different workers, right? How the RDDs are getting accessed, that we need to understand. All right. Now we will switch to the coding part, and I will try to explain you like how we can code for PySpark, right? For this purpose, I have created some code files, right? And I'm going to share those code files with you. Now it's like now it's going to be a bit some hands-on. So I request you to go to one link. I'm going to share one link actually. You go to that link and you tell me whether this link is accessible to you or not. Is this link is available to you? Please confirm. Is it accessible to you? Is the link is accessible? Oh, thanks. Thanks, Dr. Ashfaq. All right. So now I'll be sharing my screen again. Right. So these are some code files which I have created so that you can understand Spark, right? So here is the first one is for basic installation of Spark, right? You can just click over it and it will take you to one CoLab file. It may ask you for your Google account, right? So that it can be transferred. You can download it and just upload it in your drive, and from there you can open it. Right? You please let me know once you are done with this. Please put some message in the chat. Start with the first one, basic installation. Have you downloaded it? Can you access it, participants? Thanks, Dr. D'Souza. You just have to click it. It may go to your own drive, right? You just have to do that. And if it is not working for you, you can just simply save it and then open it in your drive. You have to use Colab for that, right? It may ask you for your credentials also, so you can log into your Gmail account and proceed with it. Dr. Asfaq, can we continue? All right, thanks for the confirmation. All right, thank you. Now, in this first Colab file, what I'm trying to do, I'm trying to just make sure that we are able to install Spark in Colab, right? So first one is we are installing Java, and then we are downloading the Spark setup, and then we are unzipping it, right? It is compressed, it is in a compressed form. And then what we do, we simply install this Spark, right? So you just have to press Shift Enter over here. Most of the files are like this only. You don't have to do much, but you just have to go through it, right? And then it will start fetching it from the net. And then everything is happening in Colab itself. So it is not consuming your speed. So Colab will fetch the file, this particular file, this Spark. It will go to this particular URL and download the setup. And then it is going to install it, right? And if I go to the next one also, so that it's not going to take so much time. And the lazy operation I will show. So I'm going to execute this one also so that it is ready. So it is downloading and installing, right? So you may see this kind of output. And then we are setting the Java home and Spark home, right? These paths we need to set. And then we are setting up the number of nodes and everything, right? So we are initializing our Spark and we are initializing our master. We can specify the number of nodes which we want to use. So star, we are not specifying that right now. So simple installation is done like this. So this is how the installation of the Spark is going to be done in Colab. So you have to have these 3 code shells, and with the help of this, you can actually install the Spark, right? Then, okay, then if you go to the second link on the page, right? The second page, loading data, how you can load the data. For that, what you have to do, again, you are going to install the Spark, right? You can do that. I kept them separate so that if you want to work on some specific one only, so it is there. Now I have some data already in my drive. So this is the second link which I'm accessing, loading data. And then like these three code shells are same only, right? Here I am specifying the path of my Google Drive where I have stored this data, right? You can download this data and take it to your Google Drive, right? The link is available over here also. You can download this data and take it to your Google Drive. So in my Google Drive, it is stored. Let me see if I'm able to go there. In my Google Drive, it is stored like this. My drive dataset, I have a dataset folder in my drive, and there is car evaluation.csv, right? Okay, so if how we can mount the Google Drive with this Colab. So your Google Drive is also kind of like, you can consider it as virtual disk. How you can mount that into this Google Drive? You have to execute this particular code, right? And it will ask you to connect your Google Drive. And then you have to connect it and it will get connected. You have to just give it the permission, right? Then once the connection is established, what you can do, you can actually read the .csv data, right? You can read the .csv because it's a .csv file, simple. If you don't want to connect it with your Google Drive, if you don't want to do that, in that case, what you can simply do, you can simply, you can simply download this file, right? You can simply download this file and go here in this Spark and you go to this particular icon over here and you can right click over here and simply say upload and upload the data, right? Upload that car underscore evaluation.csv file here. And once you are done with that, you can just right click over that copy path and paste that path over here, right? In that case, it will work. I have another code like this Colab sheet in which you can do that, right? You can get that from there. All right. Once this you are able to read this data, then what are the basic operations which you can perform? Those operations are mentioned in this particular Colab file. Right, so you can see the schema of the .csv file, right? So, sorry, I have to execute this first. So this spark.read.csv function will help you to get the file, get the .csv file, and it is going to be stored. So you will get the schema of the file, and if you want to see the first 5 elements, first 5 entries that you can see, right? And then you can count the number of instances in the data. And there is one describe function also, which is going to give you basic statistics about the data, like count, mean, standard deviation, minimum and maximum. So these basic statistics will be given by describe function. So these are the basic functions which you can perform. With this particular Colab file, we are able to understand that how you can load the data in the Colab file while you are working on Spark. So you have loaded the data to the Spark. All right. So this you can do using load data Colab file, which is here. Right. Then I want to concentrate over these. You can check with this also. This is also pretty straightforward. Like we will deal with lazy operations now. This we need to understand. Lazy operation. Again, the file is same only. You just have to do the same steps over here also. Now, while explaining, I told you that when we are applying RDDs operations, what is happening? We are creating a lineage of RDDs. The operations are not actually taking place. It's just in form of a plan, just planning, right? No operation is getting performed till you actually want the results, right? Till that point, nothing is happening, right? Everything is in form of plans. All right. So that we will try to understand. Here you can see I have created using parallelize. I have created one RDD, and that RDD is having a list of length like it's around 1 million, I think. Yes, 1 million numbers. Okay, so this list is having 1 million numbers, and that is parallelized. Like now we have data, reference to the data in form of RDD. How you can actually see that? You can see over here, I have executed one command, the rdd.toDebugString.decode. Now, this is giving you the information. It is not giving you any real data. It is giving the information that how this object is created. It is giving you just the information that this RDD is created, and it is a reference to the data, right? That is what it is telling you. It's not actual data. It's just it is just referring to the data, and one RDD is created, right, with the name of RDD. Now, suppose there is one operation which we want to perform. What we are doing here, from math, we have imported this cos, right, cosine function, cosine, and then we are going to define a function which is take time, and this is I, right? That is the parameter which we are going to get, and we want to calculate cosine and return the cosine value, right? And we are calculating cosine for 100 numbers, right? So now if we execute take time, right, and we are typing this time, right, command, with the help of this we will be able to get that amount of time which this particular function is taking, right? So now let me see, the installation is done, and now you can see here we have 4 workers, right? And then we have created the RDDs, and the RDD is in form of object over here. And then this is simple function just to calculate the cosine of 100 numbers, right? And then we are executing this particular function. You can see how much time it is taking, right? So this much amount of time is required when we are executing this function. All right. Now, let us say we are doing it with the in context of RDDs, right? And how we are doing this? We are saying that map lambda x, rdd.map lambda x, and take time x, right? And you can see in this RDD, how many numbers we are having, right? Okay, RDD, we have 1 million numbers. And you see how much time it is going to take, right? It is taking, here it is taking 37 microseconds for 100. It is here it is taking this much amount of time, right? So we have done the operation 1 million times, and we have calculated the the cosine values, but still the time is very less, right? Why it is? Because whatever we have done here, it is just in form of a plan. It is in form of a plan. It is not actually done, right? Now, once you apply the reduce operation, meaning you want to actually execute the plan, right? Then it is going to take the time, right? Then actually it is going to take the time. So it means that whatever the operations you want to perform over RDD, you keep on coding for that, right? But everything will be in form of references only. Everything will be in, see over here, it was in microseconds, but now it is in milliseconds. Why? The actual operation, you see that you have executed the function, you have applied the map function, right? You have passed these 20 times, you have called this particular function, right? But still you see the time was less only. When you finally need the output, then only it is going to take some time. So the concept which you need to understand from this, that in Spark, when you are applying operations, when you are changing data from one form to another form, the actual execution is not taking place. Everything is actually in form of a plan. Once you go for the results, then everything will be calculated. And that will be in form of job, stage, tasks. Again, a direct acyclic graph is going to be generated. It is going to be optimized, and then the results are going to be presented, right? This point should be clear to you with the help of this particular collab file, right? Now, if we and why we are saying it's lazy operation? So simply the literal meaning of lazy is there that Spark is actually going to perform lazy operations. Why? Because when the final results are required, it will be lazy till that time, right? It is not going to execute anything. It is just going to maintain a plan, right? And will work over the optimization of that particular plan, right? Then a simple word count program is there, right? So you can check it. I'm not going to install it again and do everything. So for example, here is like that this particular string is there, and we can use dot split to split the string based on the spaces, and it is going to come up as a list, right? And then we parallelize this particular list using the parallelize function, right? When we do that, then again we are creating one RDD. Okay. Now what we want to do, whatever the elements of the list are, we want that element comma 1. We want to perform the word count. So we can use map function and along with the lambda function. Then again, this is going to be in form of a plan, not the actual RDD. You print this, nothing is going to come as output, right? It is just a reference. Then once you execute the collect command, then only it is going to be realized or materialized when you are executing collect command. Then the results are going to be generated, right? Now, if you just want to see first 4 elements in the list, that also you can take. Now, again, you want to perform the reduce operation, right? So the reduce operation, what reduce operation is going to do, same name or same word, it is going to add the value part, right? That is what the logic you are applying, which is reduced by key, right? So the key for each unique key, the value is going to be, the values are going to be added together, right? So here we have hello 1, faculty is 1, and you can see you is coming twice, right? Even this reduce part is in form of a plan, right? It is also in form of a plan. It is not actually getting executed, right? Once you call the collect function, then the output is coming, right? So with this also, you should be able to map the laziness of the Spark. You should be able to map that Spark is not actually doing the like calculating everything at as the execution of the different program statements are is actually happening. It is waiting for time, and once it wants the result, then only the execution is taking place, right? This you should be able to understand, right? Then there are like this particular collab file will give you the understanding about key value pairs, right? In case of big data, like in case of map reduce Spark, this key value is very important, right? Key value part is very important. So you are, for example, a word count program, you are making words as keys and values are the how many times it is occurring. For example, you are having a text document, you can have name of the document as key, value part is the whatever is there in the document as value. You want a cluster, right? So the cluster, the key part can be the cluster head, the value part is the like some information about the cluster or all the points in the cluster. That can be the value part, right? So key value is very important, and you need to understand this key value operations, how this collab is actually, how this Spark is going to perform, the key value communication is going to happen, right? Now you see again the same steps are there to install the Spark, right? To like to create a Spark context, everything is same. Now, how we are going to define a key value? So we are going to use these brackets, right? Small braces are there with the help of which we can define that 1 is the key and 2 is the value for that. Again, here also 3 is the key and 4 is the value for that. And we can parallelize it in the same way. Right? We can parallelize it in the same way. And you can see it's a list of key value pairs. Again, to parallelize function, we are passing a list. All right. So now if we want to print it, right? If we want to print what is there in the RDD, so we are using collect function and we can get the result. So that is what is there. So if you want to parallelize key value pairs, again, same function you are going to take. You just have to have those key values in form of a list and you can create an RDD. Then over here, you see, we can actually generate key value pair using map function, right? So for example, we are given with one list and we want to calculate the value part, right? We want to have value in some, by applying some logic over the, whatever the elements in the list is there, right? And here, how we are doing that, we are taking one element, right, of the list, and we are multiplying the element with itself, and then we are considering that result as value part, right? So for each X in the list, we are going to result in form of X, comma, X multiplied by X. So the final list is going to, final RDD, in the RDD, we are going to store as 1, 1, 2, 4, 3, 9, 4, 16. In this way, we are going to store it, right? And then there are some functions, like I will go through these functions. So for example, one is there reduced by key. And this we have already seen, right? How we can actually reduce in the word count program, we have seen it, reduced by key. Now, in this case, for example, we have these key value pairs. So consider, see this 2 key over here and over here is actually same, right? And now what this reduce by key function is going to do, it is going to simply add the value part for each, for the same key. So here for 2, the value part is 4, here it is 6. So you will have in the result 2, 10, right? 1, it is only occurring once. So we don't have to bother about that. Here again, we have sort by key, which is going to sort the elements with respect to the key, right? So that result also you can see over here. Then we have map value function, which is apply function to each values in the RDD. Again, you should be able to see the, say this, 1 second. When we are applying this map function, it is not going to be materialized, right? If I don't write collect over here, there is no result and there is no calculation happening for this X square. This you should be able to understand. If I don't write collect over here, it means that everything is in form of plan and no calculation is actually happening, right? Everything was in form of plan only. And then there is a function of group by key. It returns a new RDD, key value pairs, and it iterates over the values associated with the key, right? So here you can see it is going to result in a, again, like in form of a iterator, meaning a list. So here we have this RDD 1, 2, 2, 4, 2, 6, and you can see the output is coming like this. For 1, we have 1, for 1, we have 2, that is the value part. It is going to come as a list. And for this, we have 4 and 6. Again, if we want to merge different sort of keys together, in this way, we can use this function. All right. Then again, there are few other functions. You can go through it. I have given the descriptions for each function, right? You can go through all these functions. So one very important is this join function, right? How this join is happening, and joins, like in relational databases also, we used to have join, inner join, outer joins, and all those sort of joins were there. In the same way, here also, when we are working with key value pairs, we need to work over the joins, right? So for example, there are 2 RDDs, RDD1 and RDD2. So the RDDs are initialized like this: 1, 2, 2, 1, 2, 2, 2, 5, 3, 1. And if you want to perform a join over these RDDs, then how you can do this? That join function is there. You are joining RDD1 along with the RDD2, and you are applying the collect function, meaning the results need to be generated right away. So you can see only common RDDs, only the common RDDs are, common values are. So we have 2 over here, but the value part over here is 1, here it is 5. So we have 1 pair in the value, which is 1, 5 for key 2. Another pair, we will have 2, 5, right, for the same key. So 2, 2, 5. For 1, there is no key in the RDD2. So it is not going to take it, right? So this is the basic join operation which need to be there.
Okay. So again, in the file, I have one more COLAB file for key value operations. There are also functions with the help of which you can manipulate key values. I will give you an example like why it is, where it is actually used. Then you can check this particular code COLAB file for implementing the support vector machine, right? So support vector machine, as like it is, I think it is covered in the talks. So support vector machine is basically for a classification machine, right? So the data is given and like there are two classes, right? Class A and class B. The idea is that we need to generate sort of plane in between these two classes so that if a point lies above the plane, we can say that is a class A. If it lies below the plane, then we can say a class B, right? Then like what we need to do, we don't actually go with one plane. There can be many possible planes are there. What is the, like, what will be the plane which gives us maximum accuracy, or how we can ensure that the margin between the between two classes is maximized, right? So for that, we go with the maximum margin plane, right? And it's not a plane actually, now it becomes a sort of road between two classes, right? So a canal between two classes, right? Instead of one line or one plane, right? So that need to be done. Okay, so you can go through this, and here, like this is how we are going to approach to the problem. So this is the plane, and then the different, we call these boundary points as support vectors. So the idea behind support vector machine is that we need to calculate the support vectors, and we need to maximize the distance between these support vectors, right? So the support vectors of different classes, we need to maximize the distance between them, which will result in maximizing the sort of width of this particular canal between the two classes. And then we fit this particular plane over here. We find the equation of this plane. And when we have a point which we want to classify, we apply the dot product of that point with this particular plane, and we try to find out where that point lies, above this plane or below this plane, right? Now, how we can fit this in terms of Spark, right? How we can do it in terms of Spark? The overall complexity of support vector machine is going to be, worst case complexity, if I say, is going to be order of n cube, right? N cube is like it's a very high, right? If you have more number of a very large number of points, if we talk about big data, if you have large number of points, then it's going to be very difficult to manage n cube, right? Then how we can approach to this problem? How we can approach this problem? The idea says that our overall goal is to find out the points, right? Find out these support vectors. And now you see, in this case, if we have only 60 points, then we are getting these support vectors. Now, if we have more points, suppose we have 60 more points, then we are getting more support vectors. Now you consider these points are available on one machine and these points are available on another machine, right? And see, everything is done in a very neat and clean manner. Then how we can actually combine the equation of what we are getting from here and what we are getting from here, right? In my morning talk, you may have seen I was talking about that when, like whenever there is a processing unit, what that processing unit must result in. That processing unit is going to result in form of information or in form of data, right? So this machine may say that I have these many support vectors. So instead of sending the information about all these points, right, it may send information about only about the 2 points which are at the margin, right? Which are at the margin. Let me see 1 second, students. Oh, sorry. Now, instead of sharing all the points, it may share only the boundary points, right? And this machine also is going to share the boundary points. Though some points are common here, but even if you consider that the points are totally different, the margin point, the boundary points are going to be important point. So that comes under the second category. When the machines are not going to share the information, they are going to share the data, the reduced data, right? And that data can be collected in a centralized point. And again, we can apply the support vector machine, right? We have developed this idea, right? I'm going to share it with you. We have developed this idea and we came up with very good results with this, right? So now another problem in context of support vector machine comes when we are dealing with data which is not linearly separable, In that case, how we can deal with them, with this type of data, right? You see, we cannot fit a plane in when the data is looking like this. Then there are kernel methods with the help of which we are going to take this lower dimension data into high dimension, right? And then we can say, like, this data is in 2D. If we take this data into 3 dimension, then this data, we can fit some plane between this data, right? So when we when we take the data to higher dimension, then we can actually fit the plane between that, right? Now, this is sort of about this support vector machine, and you can find some problems in context of face recognition also in this CoLab file itself. You can go through that, right? So my idea over here is that why I want to introduce support vector machine here is that how we can actually distribute the task of finding out these boundary points, right? Given certain amount of data, how we can distribute that, right? So like that sort of in that way, we need to think when we talk about support vector machine, so that it can be applied over big data, right? So that it can be applied over big data. In that way, we need to think over it. All right. So now there is Spark data frame. This CoLab file is there, right? So how we can actually read the data and create a data frame. Spark data frames are actually a little bit different from the pandas data frames, right? So that we need to take care of, and we can create different data frames. We can provide the schema, we can provide explicit schema, right? Here I'm giving the data directly so that the data frame can be created, right? We are creating RDD only, and we can provide the schema for the data frame, right? So we can convert this RDD into so that it can be considered as a data frame, right? And you can see once you have data into form of a data frame, you can apply all sort of machine learning approaches over there, right? So that can be done. And we have a create data frame function with the help of which whatever the data you have in RDD, you can take it to the data frames, right? You can specify schema explicitly so to create data frames, okay? So that also can be done. And while you are going through this particular CoLab file, you should be able to do these tasks. Create an RDD with 5 columns, convert the RDD to a data frame, and define an explicit schema for student information if you want to store student information. Create a student information RDD using row function, like this row function is here, right? Okay, and then you should be able to transfer the data from RDD to data frames. That also you should be able to do. So all of these tasks can be done based on this this particular code, right? So why we need data to be in our data frame? So that we can analyze it in a better way, right? There are tools available which works over the data frames, right? Directly over the data frames. Then again, different operations are there which you can perform over the data frames. That also you can refer through this code CoLab file, right? Here I have given the link for the dataset also. You can download this dataset, upload it to your CoLab, and that can also be like you'll be able to work over this also, right? Now, I want to brief you about one very important. All of these operations you can perform. Description is given in the file, right? You can actually see what is happening with the RDD. You can see when it is in form of a plan, when it is actually getting executed. Now I want to give you example about the streaming of the data, right? Why I'm talking about streaming? Streaming is basically it's a like you have a sensor mounted, right? Like even if you are wearing a smartwatch, that smartwatch is continuously generating data. So the data is coming continuously, right? And we can say that it's a stream of data, and that you have to analyze that stream of data instead of going through that. You have a data set, and over the data set you are dividing the data set into, say, some training part is there, testing part is there, and then you are training your model and then deploying that model, right? So it's a kind of offline process which you are doing, right? But once you have data which is coming continuously and you want to work over the data, right? You want to analyze that data. You need to have a streaming platform through which you are continuously sort of injecting the data to your model, right? That need to be done. So if you please check this particular CoLab file, Spark incremental data processing, right? And there is a data set also given, right? There is a data set also given. If we click over this particular drive is going to open, right? You please tell me whether it is accessible to you or not. So you must do now this particular, you must access this 7th CoLab file, which is Spark incremental data processing, right? Please confirm if you are able to access it, and confirm also whether you are able to access the data set or not. Are you able to access the data set? Please say yes or no. All right. Thanks, Dr. Abdul. Thanks for confirming. All right. So I will proceed with that. See this data set, right? What you need to do, you can download this data set, right? So like you can download few files if you are like just going to press Control A, right? At this time itself without scrolling it. So 50 file will get selected. But now I have scrolled it down. So I am having 100 files, but I think the files are more, right? So we have more files in this particular data set. What this data set is about, continuously the readings are coming, right? And at each timestamp, new .csv file is getting created, right? A new .csv file is getting created. All right, you can see continuously like these files are I have so many files are there, and these files are numbered based on the timestamp, right? And if I say Control A, so I have 305 listed, 305 files listed, right? And these files are for different timestamps, right? So the data is getting generated continuously, and we are getting new files in an incremental manner. Suppose this is happening continuously, right? So now we need to inject this data to the model. It means that we need to specify what is the model here. That let me show it in the slide here. One second. So the idea which is used, that continuous data is coming, it is getting stored in one particular drive, right, or on some disk, and this disk is continuously accessed by Spark context, right? It is continuously accessed by Spark context. Now, as new data is getting added, that need to be getting reflected over the Spark context, right? So this incremental streaming, we need to ensure that this streaming is happening in the Spark, right? So how we are going to evaluate it, how we are going to sort of do this experiment. So what I'm going to do, I will load those .csv files in a directory, right, in the CoLab, right? And then I will make Spark context access that directory. And then I will apply some operation. I will perform some operation. And then like when I'm going to perform the operation, say at 1 second, I will check the output. So some output is coming, say some variable is resulting as 10. Then after 5 seconds, again, I'm checking, right? And at that time, this parameter is going to change, because this, you consider this parameter as some sort of sum, which I am taking. So it's a sum of different values, right? So these CSV files. So first, this 10 is the result of say first 10.csv file. Then after 5 seconds, I need to get more CSV files. So more CSV files come, then this sum gets changed to say 90, right? And that is based on the next 20 files. And then again, as continuously new files are getting added, this result is continuously going to change, right? So a stream of data need to be established. So here in this particular data set, how many files I'm having 305 files, right? So, and in this Spark here, I have only uploaded 50, right? And then I will see that how this particular incremental approach is working, right? That we will see with the help of this, right? Again, the task is same, right? We need to install this Spark, right? And the code is like this only. And then we need to set the Java home and Spark home, and then we will be initializing Spark with the number of nodes. And this this is not for your use, so you have no need to execute this particular unzip retail file.zip, right? Because initially it was in zip form, so I unzipped it. So now here, here we are checking the schema, right? Again, we are using the data frame. We are creating one object with the help of which we can read the .csv file, right? And we are creating the schema, right? What sort of schema we need. So we are going to read one example file, right? And that example file we are going to access. Okay. Suppose if you are finding problem in loading data over it, what actually you have to do? You have to you can create a new file. You can create a new folder. Right? And give this folder some name. So I'm giving it as retail 1, right? And then you can just click over this and go over here and say upload, right? And in this retail folder, the files which you may have already downloaded, you can just say Control A and upload it, right? So in the retail folder, all those files are going to be uploaded, right? And if you miss the track that where that is, let me just. It is in the content folder, right? If you came out of it, then you should check the content directory. So my data, I have already uploaded it in the retail directory. So here the data is there in this retail directory. And I am just trying to access one file so that I get the structure of the schema. So if I do that, then I'll get the structure of the schema. Then you can see what sort of schema it is. Now I have written some observations over here. So now we will use Spark Stream to stream the dataset. So dataset is already there. Dataset is not one file. It is continuously getting streamed. Now you can use some other tool which is injecting data to your pool, right? Like Apache Flume is there, right? So Kafka is there. They are continuously going to inject the data in the pool, right? And like what we are going to do, we are going to create a stream from this, right? So if you have downloaded the data, a zip file may have got downloaded, you unzip that and upload all the CSV files over here, right? This you should be able to do. Now in my case, it is actually not retail file, it is retail only, right? This retail, right? Now what I'm going to do, I have already downloaded it, right? And now I'm going to create a Spark stream, right? So that this is the form, this is the sort of logic for Spark creating a Spark stream. And here, if I just say, we need to define the path over here, right? And we are putting star over here because we are not specifying any specific file to load. We are continuously going to read all the files, right? So if I execute this, then we can check whether it is streaming or not. Then if it is resulting as true, that means it is streaming. Then we are going to import these packages, right? And then here we are going to apply a lazy operation on the streaming data frame, right? So that we can get the required list. So here and here you can specify the sort of one name to the query. Okay, I have already executed it, so I'm going to change it. So I have customer underscore purchase, and I have given this name. If this name need to be changed, you can change that name, right? And then I'm going to execute one query over it, right? So this is the SQL query which I'm going to represent, which I'm going to execute. And you can see the output over here. So first 10 results I'm looking at, only first 10 results, right? So now you can see the output is coming like this. Okay, so you can just observe the numbers which are there. So I have 8132 over here, 442 over here, and I'm going to execute it again. You execute this again, right? So I hope these numbers are going to change. So now those numbers got changed. So one question is there, how to capture stream data as .csv file from accelerometer sensor for smart watch and mobile phone. Okay, so the question is that how to capture the stream data as .csv from accelerometer or sensor. So that we need to go to the device level, right? So the Spark will take care from the point when you have data in .csv or in the format in which you are getting it, right? So even if you have, say, data in some other format, so instead of calling it in form of .csv, we will use that. If the format is compatible with it, we will use that format, right? So we are not I'm not going to comment like that how we can directly take the data. We need to see the data in which format your accelerometer is actually generating the data, and then can we convert the data into .csv? That is the straightforward way which is coming to my mind, right? But if the format is compatible with the Spark data frames, then we can directly call it and it will work. I hope I'm able to answer your question, Dr. Asfar. Okay, thank you. So now you can see the values got changed. And again, if we do the same thing, if I'm going to generate execute it again, this is getting changed, right? So every time I'm executing, it will keep on changing till it is going through all the files over here. It is going through all the files till that time it is going to change. Otherwise, it will not change. All right. So this is about how we can get the Spark stream. How we can get Spark stream. Okay. Then after this, we have, I hope you are able to do this, right? If you are facing any problems in starting the Spark stream, you must let me know, right? And then we have the Spark k-means clustering also, right? So you can find the logic for k-means clustering, how you can perform k-means clustering using the Spark, using Spark tool, right? So how you can fetch the data, what are the steps you are going to perform, right? So now the question is that how, you can take it as your work. So how you can actually map the data in form of stream like this, how you can mix these codes together actually. So you are getting a stream of data and how you can feed this data to your k-means model, so that each time when new data is coming, your clusters are getting changed. Each time. When a new data comes, your clusters will get changed. So how you can establish a Spark stream, right, which is continuously changing, and then based on that data, as new data is getting added, your clusters are going to get changed. How you can establish that, right? So that you can work over, right? If you are able to do that, it's okay. Otherwise, you can approach us to we can help you in that, right? In the same way, there are different approaches. One second, let me just conclude over it. So, for example, as new data is getting added, right? So, as new data is getting added, so you will have some centroids at one point of time. After the new data is going to come, you need to update those points again. continuously you need to work over that, right? So how you can establish a parallel k-means clustering by using a Spark stream, right? How you can do that. And then there is one more sort of idea which I want to give over here, is that there is one another approach for clustering, which is BFR algorithm. This is also can be done in a way of Spark stream. The idea is very simple over here. So the assumption is that the data is actually divided. The data is actually like having a normal distribution, right? Each cluster is having a normal distribution, and it is separable also, right? So one cluster is, you can find clear clusters, right? This blue cluster is there, this pink cluster is there, right? So these different clusters are there. And now what is the idea here is that, so instead of going with clustering, what is going to be done? The points are going to be compressed together. So whatever the points close to each other, they are going to compressed. And once it takes the structure of a cluster, then only you are going to consider it as cluster, and you are going to come up with 3 new data structures, which is discard set, compressed set, and retained set, right? So some of the points you are going to discard, right? And some of the points you are going to compress. You are not going to store the point. You are not going to store the point. You are going to store the information about the point. What is the information and what is the point? But what I mean by that, so for example, in case of k-means clustering, when you work over k-means clustering, you need to maintain you need to find out the average with respect to the distance of all the points, right? How you can do that? How you are going to do that? So instead of storing the point, like when we say discard set, what is going to happen? We are going to sum the points dimension wise, and that we are going to store, and we are going to store this sum square also dimension wise, right? So if we are maintaining only these variables in the memory, we are losing the points from the memory, right? So as new points are getting added, we are just summing them dimension wise, and we are just keeping the squared sum also. So if we have only this information also, we can update the centroids, right? We can find out the average because sum is there, and we can find out the standard the variance also, right? And we can go with the standard deviation also. So we can find out that. So how you can see the continuous data is going to be generated, and you are going to compress that in form of some variables. Again, you can use Spark stream for this purpose, right? So with you can load different points in the main memory. So you are going to load the points in the main memory, and finally what you are going to do, you are just going to calculate the sum, right? And this is this is known as BFR galaxy picture. So we have we have the discard points, we have compressed point. Compressed point also we are going to keep the sum and squared sum together, and some of the points we are not going to combine them with any of the compressed points. Suppose we have started with 1 million points, and now because we have reduced, say, half of the points in one cluster, so we can say discard all those points. So that much amount of memory we are going to free up. And then we have some clusters, sort of compressed points. Still we are just keeping metadata about those points, but they are not in form of a cluster, right? And some few points only we need to maintain in the main memory. So in this way, we can actually reduce the amount of data which we need to keep in the memory, right? So this sort of work can also be done with the help of Spark streaming, right? So while concluding with my talk, I will say that we have discussed about big data analytics. We discussed about MapReduce. We discussed about Hadoop. What is Spark? What sort of how the classification can be done using Spark, and then clustering, and then incremental learning, and then different use cases also we try to understand, like in case of BFR, right? And another we discussed about in the morning, we discussed about association rule mining, right? So this particular link will be up, right? You can use these resources if you face any problem. If you are not able to access anything, if something is not running, you can contact me, right? And that's all from my side. Thanks for inviting me. If you have any question, you can please ask. Any question? Am I audible? Am I audible? Okay, thanks for the motivation. Yes, you can access this link. It will be there. Dr. D'Souza, you can access this link. Most welcome, Dr. Ashfaq, Dr. Pooja, Dr. Madhu Babu. Thank you. Thank you, Dr. Murthy. Thank you, Dr. Vishnu. Kapil. Thank you so much for your appreciation. Thank you. Thank you. Dr. Abdul Santosh, Dr. Vinaya Shri. Dr. Sandhya, Dr. Madhu Babu, Dr. Joseph. Thank you so much.
ఇప్పుడే లింక్ వచ్చింది కదా. ఆన్సర్ మాకేం తెలుస్తుంది చెప్పండి, వెతకాలి.
able to attend this session. The session being in hybrid mode was one which helped both the people who are inside as well as people who presented online. So combination of that, and the people made it a huge success. The session began with the chief. So the session began with the committee staging the lamp for the inauguration. This was followed by the chief guest, Dr. Kiran Kumar, who provided an insight into the fundamental concepts of data science. And he pulled the people who are into business and showed how data science can be applicable to business. So many of the participants got a wonderful insight into this. The same day, during the evening session, Mr. Pavan Kumar gave a presentation on the various aspects of DevOps and how they can be used in industry. Then he followed it up with a practical demonstration of usage of these concepts. And the tools to run DevOps were also demonstrated, which attracted wide variety of appreciation. The second day, Dr. Anand spoke on the concepts of fuzzy logic and how they could be used for machine learning and how it is applicable to machine learning, and also some practical demonstrations of using MATLAB, which can be carried out for research. Then the afternoon session was taken up by Dr. Prasad Illa, who is a solution architect of tech systems, who projected the level of industrial applications by demonstrating brands of Angular nodes, MongoDB, and Express.js framework. He also showed how these tools could be used for real-time applications by demonstrating the same on the next day morning. During the next day afternoon, a session of cloud computing was given by our Honorable Vice Chancellor, who not only talked about cloud computing, but also talked about the environmental aspects and the hazards, how the emissions, the carbon dioxide emissions, the effect of CO2 emissions, and the environmental aspects which take place. The day 4 began with a session by Dr. Nagarajan, who just not talked about the machine learning algorithms alone. He started with a domain. For every domain, how you can incorporate a machine learning algorithm. So how a domain needs to be understood. Once you understand the domain, he also told which machine learning algorithm which will be more applicable and why. He gave a demonstration with Python showing those subtle aspects. During the same afternoon, Dr. Neelima demonstrated the usage of machine learning exclusively towards healthcare applications. So what aspects of the healthcare can be solved by which machine learning was neatly demonstrated that day. The day 5 began with Dr. Amrit Paul, sir, who enlightened the gathering, who made the data analytics understanding very simple, even for a layman. The way he projected the session, even a schoolboy could understand. This session was further expanded by Dr. Tulsi Prasad during the same time, where he used the concepts with machine learning algorithm applications. So Dr. Amrit Pal introduced the concept of big data analytics. Dr. Tulsi Prasad built on the topic by identifying various steps and also identifying the correct choice of tools and its pitfalls. He then introduced that machine learning concept, which Dr. Amrit Pal later demonstrated to the audience how to implement using Spark. The participants provided a wonderful response, not by just giving the feedback, but also asking the right questions to the resource persons, which in turn benefited not only the faculties outside, but also the internal faculties. So in short, the session was found to be a great success with participants from across the, I will not say across the world, because only 2 people were outside the country, but actually it went in a global manner, and based on the participants' requests, we feel more such sessions should be inaugurated in future. They have given the motivation and impetus to all of us for continuing in the right direction. I am sure Anurag University on a whole will be the starting point for many people to carry out research and also to conduct such programs successfully in the near future. With these few words, I would like to thank one and all who have assembled here. Thank you once again.
Thank you so much, sir. It's true that many participants have got benefited and they're expecting many workshops from us. Hope this will continue. It is now the time for all to receive their certificates. We as a team, on behalf of the FDP's organizing committee, are requesting our Vice Chancellor, sir, Registrar ma'am, HOD sir, Dean sir, to distribute the certificates to our offline participants. I now read out the names. Please come on to the dais, sir. Mr. P. Ashok, H&S, Anurag University. Mr. N. Venkatesh from CSE. Sorry, Math Department. Dr. P. Mangatai, H&S. Dr. C.H. Vijay Bhaskar, H&S. Mrs. Talla Hemalata, Madam, ECE. Mr. G. Prabhakar Raju. Mr. G. Prabhakar Raju, CSC. Dr. P.V. Kumar. IT. Doctor. Later. No. Dr. M. Anil Kumar from Maths Department. Thank you, sir. Thank you, sir. Please, if somebody could give us a feedback from your end, we'll be happy to listen from you. Feedback from the participants. Online or offline? Organizing committee. Yes, sir. Yes. Sir. These certificates. Amilga. Chepandi Ramachandran sir and resource person sir, Krishnanand sir. We are happy to share. Certificates now are issued for the resource persons. Professor S. Ramchandram sir, Vice Chancellor, Anurag University. Dr. S. Krishnanand sir. Dr. S. Krishnanand sir from AI, Anurag University. It is now the time for the organizers to receive the certificates. I now request Dr. A. Mallikarjun Reddy sir to take his certificate. Dr. S. Krishnanand sir. Dr. Abdul Ahad sir. Dr. Basavaraju sir. Dr. P. Pradeep Kumar sir. Yeah. Istunam sir. Basavaraju sir.
Dr. Pardeep, sir. Dr. Manoranjan, sir. Madhavi వస్తుందా? Mr. M. Hariprasad, sir. Mrs. Deepika, madam. Mr. N. Raghu, sir. Mr. Victor Daniel, sir. Mrs. Neeta, madam. చెప్తారా ఇవన్నీ? చెప్తా. Shilpa, madam. Lakshmikant, sir. Jagan Naik, sir. Madhavi, ma'am. Thank you so much. Yes. Online participants can raise their hands to give the feedback. I request the dignitaries to please be seated. Please కూర్చోండి, sir. Participants can unmute themselves. We would like to hear from you. Offline participants are requested to give the feedback from your side. I request Anil, sir. Please share some views on this FDP.
Sir. Respected dignitaries on the dais and my colleagues, good evening to one and all. And myself, Dr. M. Manil Kumar from Mathematics Department. I say one important thing here, the session is very useful. And as we know that DevOps is a set of practices that combines the software development and IT practices. And here what we understood is it is not possible to deploy the source code on the production servers directly. So in between, there are so many mediators like GitHub, Jenkins, and Maven. And in the session, we clearly understood what is the role of GitHub. Okay, now how it works as an interface. And of course, we are not from the computer background, but here we understood what is the role of Jenkins and what is the importance of Git and how the source code is converted into RAR files and jar files. And finally, what is the process we understood. And really, we thanks to the organizers, especially AI department, and thanks to the management of Anurag University. And I thank to VC and Register sir and head of the departments. Thank you one and all. Thank you.
Sir, feedback can be given? No? Online feedback.
Anyone there? Enter in the chat box. Okay.
May I give
Placing the messages, sir, in the chat.
feedback, ma'am? May I give the feedback, ma'am?
Conduct more such FDP programs regularly online. Sure, sir. We request our EC sir in management and will share the same. You can unmute yourself and can ask, please, we request you.
Yeah, I've unmuted the mic, ma'am. Are you able to hear
We are
me?
able to hear you, ma'am. Please continue. Pooja, ma'am, please continue.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon. Yeah. Fatima, ma'am, how are you? Yeah.
Ma'am is good.
Mallikarjun, sir. Hello, sir. Good afternoon, Vijay Kumar, sir. It was glad and I'm very glad to attend this FDP. I'm working as a HOD in the Department of Robotics and Artificial Intelligence. And it was an eye-opening session for me because I have to look into the curriculum of the students and as well as the VTU curriculum, what has brought in for the AI. I think the experts were excellent. All the speakers were excellent and the support given from the university was excellent. Thank you, sir.
Thank you so much, ma'am. Any other participants?
Yes, ma'am.
Please continue.
Hello. Yes,
Please
ma'am.
continue. Please continue.
Good afternoon, one and all. Respected
afternoon,
Vice Chancellor Sir Ramchandran Sir and Fatima Madam. I feel very great to have such type of session. I have constantly listening all these sessions from Monday onwards. I am from Anurag Engineering College for that. My name is Dr. V. Srinivasarao. I feel very pleasure getting all the what you call the new technologies into one platform. Here we have registered 3 members from Anurag Engineering College for that, and it's a very it makes us to have listen all the new technologies, and we'll be seeing further in future also to conduct more and more FDPs like this, and we would like to participate in this. Thank you very much for the management of Anurag Engineering College. Thank you very much.
Thank you so much, sir, for sharing your views. Any other participants through online and offline? We request online and offline participants to join us for a photograph. Please switch on your cameras, your videos, please. We request all the participants to join us for a photograph. Thank you so much, sir. We are blessed to have such dignitaries. Hope Anurag will give us many more chances to conduct many more workshops and programs like this. Thanks to VC sir, Registrar ma'am, Dean sir, HOD sir, and the organizing committee. Thank you one and all. Thank you, participants, without whom it couldn't been possible. Thank you so much.